Express 721 as a product of its prime factors. So how do we approach? So we have 721 and we are straight away going to prime factorize it. So we can do it like simply 7 into 103. And is 103 a prime number? Is 103 a prime number? So that will be the question. So you have to build the practice so that we can quickly have a feeling that whether a number is prime or not. Otherwise you can actually try different factors. In this case 103 is a prime number, so 721 can be prime factorized as 7 into 103. Okay, determine the prime factorization of 13912. So we have 13912. So 13912, we know it's an even number, so let's start with 2. 2 into 6956 you will get, then you continuously do, you'll get 2 into 3478. You can further do 2 into 1739. So we have 1739. Now the confusion will be, how do we factorize 1739? One way is that we go by the numbers 2, 3, 5, 7, 11 like that. That is one way to do it, but that may take a lot of time to eventually get to the correct factor. One thing that we can see is that the last digit is 9. Okay, so how can we get 9? So 9 can come, means 3 can be a factor, or we can have 7 as a factor. And if you try 3 and 7, both 3 and 7 will not factorize 1739. So we can continue to do, you can actually look for prime numbers like 13, try 17. There is no point in checking 19. So how do we get this 1739? Okay, so 1739, what we are looking, we are seeing two numbers should be multiplied to get 1739. Okay, and we have the last digit as 9. So the last digits of A and B, right, it has to be either 3 or it has to be either 7. So some numbers with the last digit 3 into the some number with the last digit 3. So some number with the last digit 3 into some number with the last digit 3. So the last digit 9 can be only obtained if we have some numbers like, okay, and this has to end with 3 and this has to end with 3. Okay, then when we multiply these two numbers we will get 9. Okay, there is one more possibility, it could be two numbers with the last digit coming as 7, then also we can get 1739. So now you have to actually try some numbers to get it, and when you actually try it out you will get the answer as 37 into 47, and 37 and about 47 are prime numbers, so we finish our prime factorization. So the point is that once we know, okay, basically 3 and 7 is not going to factorize this, then it is better to look for prime numbers which is ending with 3 and 7 and try to see which number can factorize it. So this is one question which starts very seemingly simple, but then you end up with some number and you can actually spend a lot of time, and you can also build tension in solving this problem, like why I'm not able to factorize it. You can even be thinking that, okay, is 1739 a prime number or not? So when you build more practice, you will have the confidence of facing these scenarios, and also you will also have a fair idea about what are the prime numbers. So next time when you see a problem, you immediately know numbers like 37, 47 are prime numbers because it comes by practice. Now we go to the next problem, that is explain why 3 into 5 into 7 plus 7 is a composite number. So what is a composite number? A composite number is a natural number and it is greater than 1. So it has more than 2 factors. Okay, So in other words, it can be divided evenly by the numbers other than just 1 in itself. So let's say what is a composite number. For example, 9 is a composite number. Why? Because 9 has factors as 1, 3 and 9. So it has not just two factors which is 1 and 9, but there is one more factor 3 here. So it has more than two factors, which means 9 is a composite number. So in the given problem we have 3 into 5 into 7 plus 7. Now how do we check whether this is a composite number or not? If it can be written as a number which is having more than two factors, that means it is a composite number. Okay, so this we can rewrite it as 3 into 5 into 1. Okay, this I put it in bracket plus 1, and all together is multiplied by 7. Okay, so this 7 will come here and this 7 will come here, and then we will get the same number. Okay, now what have we seen? So whatever this number is, we have first factor here, we have second factor here, obviously we have 1, and whatever this number is, that is going to be another factor. So what it shows is that this is a composite number, and we can show that it is a composite number by writing it in this form as a multiplication of two different integers. For some integer m, every even integer is of the form. We have been given four options. So one is m, second option is m plus 1, third option is 2m, and fourth option is 2m plus 1. To solve this, it is better to go by one and see whether which one will satisfy the correct answer. Okay, the first we have m. Now can we say that for every integer m, every even integer will be of the form as m? I think quickly we can know that it is not. If m is an odd number, then simply m cannot represent every even integer, right? So we can quickly understand that option 1 is not the correct option. Let us look at the second option. Okay, the first case is that if m is an odd integer, then m plus 1 will become an even number. That means option B can represent every even integer, but that is only the case when m is an odd number. What if m is an even number? If by chance m is an even number, then m plus 1, that is option B, will become an odd number, and it cannot represent every even integer. So option B is also a false option. Let us look at the third option. So option 3 we have 2m. Okay, now if m let it be an odd number or let it be an even number, irrespective of the case, we know if we take any integer and you multiply it by 2, you will actually get an even number. So option C will always represent an even number, and option C could be the correct answer. Okay, now you don't actually have to check option D or the fourth option, that is 2m plus 1, but since we are learning by solving problems, it is good to analyze the option D and see what we can learn from it. Okay, so option 4, let m be an odd number or m be an even number. When you actually try to compute 2m plus 1, you will see that let it be any number, it will always represent an odd number. Okay, if you have some doubt convincing yourself, let m be 6. Okay, so it is an even number. Now 2m plus 1, it will be 2 into 6 plus 1, and what will be the answer? It will be 13. It is a odd number. And let's take m equal to 7, which is an even number. Let us calculate 2m plus 1, and what will come? 2 into 7 plus 1, and it will come to be 15. Okay, again an odd number. So what you can see here, when we do this 2m, okay, which is our option C, you will always get an even number, whatever be the value of m. So 2m will always result in an even number, and 2m plus 1 will always result in a odd number. So option third is the correct option in this problem. This is the correct option. For some integer q, every odd integer is of the form. We have four options: q, q plus 1, 2q and 2q plus 1. Okay, so this time I will not go through all the four options in detail. It will be repetition. In the previous question we have already analyzed all the four options and how these numbers behave, and now you will know that option D, okay, that is 2q plus 1 is the correct answer. Because why? First case, let's see, q is even. We have seen that 2q plus 1 will always be an odd number. We have just seen this behavior in the previous question. Now the second case, q is not number, then again 2q plus 1 will still result in an odd number. So option 4 is the correct answer. So if you still have some doubt, you go to the previous question and clearly go through the way I have explained in the options, and then try to solve it, and then try to solve this question. If you still have some doubt, you can write it in the comment section. I will try to explain it later. Check whether 6 power n can end with the digit 0 for any natural number n. Okay, so how do we solve this? We have the number 6 power n, and that we can rewrite it as 2 into 3 whole power n, okay, which is same as 2 power n into 3 power n. Now can this value, whatever be the value of 6 power n, will it end with the digit 0 for any natural number n? That's a question. Okay, so if any number 6 power n for any natural number n, and if it were to end with the digit 0, then what we can understand, it should be divisible by 5. Okay, so that's the thing that we have to check. Okay, now what happens when we factorize 6 power n? We saw the factorization coming to as 2 power n and 3 power n. When we factorize, we see that the prime factorization will only contain 2 and 3, and 5 is not here. That means we cannot divide this number with 5, or in other words, there is no natural number n for which 6 power n ends with the digit 0. Okay, we move to the next question, that is, if the HCF of 65 and 117 is expressible in the form of 65m minus 117, then the value of m is. We can start this problem by first finding the HCF of both the numbers, starting with 117. So 117, we can factorize it as 3 into 39, and 39 we can further factorize it as 3 into 13. And now that 13 is a prime number, we can stop the factorization. So 117 is equal to, we have 3 into 13, or 3 square into 13. Similarly, the second number 65 we can factorize it as 5 into 13. Therefore 65 is equal to 5 into 13. So together HCF of 65 and 117, we can write the common factor, and that is only 13, and the lowest power is again 1. Thus 13 is the HCF of 65 and 117. Now it's given that given 13 is expressible in the form 65m minus 117, so we just have to equate 65m minus 17 to 13. Let us do that. 13 is equal to 65m minus 117, or 65m equal to 113 implies m is 2. So the answer is m equal to 2. The largest number which divides 70 and 125, leaving remainders 5 and 8 respectively is. To solve this problem, it is good to first represent both 70 and 125 with its divisor, quotient and remainder. That is, 70 we can write it as 70 is equal to some integer b multiplied by the quotient q plus the remainder, which here is 5. Similarly, 125 we can write it as 125 is equal to some integer c multiplied by the quotient q along with the remainder 8. We can represent any integer in this form, right? We will now rewrite the same equations. The first equation we can rewrite it as, if I take 5 to this side, and in the second equation I take 8 this side. The first equation becomes 65 is equal to BQ. The second equation becomes 117 is equal to CQ. Now we need not worry about what is the value of B and what is the value of C. The point here is that we have considered Q to be the highest factor of 70 and 125, and Q is also the highest factor of 65 and 117. So we have to find the highest common factor of 65 and 117 to get the value of Q. And once we get the value of Q, we will have the answer for the given question. Thus, the HCF of 65 and 117 is 13. We have just calculated the HCF for the same numbers in the previous problem, so I am not rewriting it. Thus 13 is the answer for the given question also. Thus 13 is the largest number that will divide 70 and 125, and it will leave the remainder 5 and 8 respectively. So any other similar problem that you can get, you can represent the same way and continue to do. We have to first represent the numbers in this form, and then we can transform it into this form, and then we have to find the HCF of these numbers. If two positive integers a and b are written as a equal to x cube y square and b is equal to xy cube, x and y are prime numbers, then the HCF of AB is. So it is a very simple problem. We are already supplied with the prime factorized form of a and b. Let us write it. So a is equal to x cube y square and b is equal to x y cube, and it is given that x and y are prime numbers. Therefore HCF of a and b all we have to do is we have to first write the common factors, which in this case are both x and y. So x here, y here, and the smallest power of x is 1 and smallest power of y is 2, or simply x y square. The answer is xy square, or option B. Can the number 15 power n being any rational number, end with the digit 0, give reason? So first of all, for any rational number n, 15 power n, we can rewrite it as 3 into 5 whole power n, or 3 power n into 5 power n. Now we have seen similar questions previously. In the textbook there is a problem considering 4 power n, and previously I have discussed a problem with 6 power n. Both were asking the same question, that is, will it end with the digit 0? So when we considered 4 power n and 6 power n, what we were looking is that whether 5 is a factor in the prime factorization of the number. And when we observed that 5 is not available in the prime factorization of those numbers, we understood that there can be no number which will end with the digit 4, 4 power n and 6 power n. In this problem, we can straightaway see that 5 is already a factor to this problem. Does it mean that for any rational number n, will 15 power n end with the digit 0? Actually, the correct way to look at this kind of problem is that to have a number which ends with 0, we need that the number to be divisible by both 2 and 5. In the previous problem with 4 power n and 6 power n, we already had 2 as a factor, but we didn't had 5. In this particular problem, considering 15 power n, we have 5 as a factor available, but we do not have 2. Once more, in this problem, 15 power n is divisible by 5, that is correct, but 15 power divisible by 2, that is not possible. Thus, the overall answer is no. 15 power n cannot end in a number ending with 0. The least number that is divisible by all the numbers from 1 to 10, both inclusive, is, the options are A 10, B 100, C 504 and D 2520. How do we solve this problem? What we have to do is we have to find the LCM of 1, 2, 3 all the way up to 10. We will now prime factorize all the numbers starting from 1 to 10. For 1, we have 1 as the only factor. For 2, we have 2 equal to 2. And for 3, we have 3 equal to 3. For 4, we can write it as 2 into 2 or 2 square. 5 is same as 5. For 6, I can write it as 2 into 3. For 7, it is simply 7. For 8, it will be 2 into 2 into 2, or simply 2 cube. For 9, it is going to be 3 into 3 or 3 square. And for 10, the prime factorization will become 2 into 5. So what will be the LCM? To calculate the LCM, we have to list down all the factors available. So those are 2 into 3 into 5 into 7. We have to also use the highest power of each factors. So that is going to be 2 cube, 3 square. For 5 and 7, it is simply 1 as the highest factor. So let us calculate. It will come to be 8 into 9 into 5 into 7, or the final answer is 2520. Therefore, option D is the correct answer. 2520 is the LCM of all these numbers. Find HCF and LCM of 65 and 112. For 65, we have done even in previous problem. It is simply 5 into 13. For 112, I can simply see 2 is a common factor, so I can write it as 2 into 56, and for 56 it is 2 into 28, and for 28 it is 2 into 14, and further it is 2 into 7. So let us write it together. 65 is simply 5 into 13, and for 112 it will become 2 power 4 into 7. Now the question is, what is the HCF and LCM of 65 and 112? So for HCF, we have to find the HCF of 65 and 112. And for that, we have to write the common factors of 65 and 112. But do we have any common factor? We can see that there are no common factors between 65 and 112. In other words, 65 and 112 together form a coprime. So therefore, HCF of 65 and 112 is simply 1. We will now also calculate what is the LCM of both these numbers. So LCM of 65 and 112, we have to list down all the common factors. We have to list down all the factors. So that is 2, and then 5, and then 7, and then 13. Now let us write the highest power of each factors. So for 2 it is 2 power, and for rest of them it is simply 1, and you just have to multiply all these numbers. I'll leave it as an exercise for all of you. Anyway, I will do it, and that will come to be 7280. Since we know that 65 and 112 form a coprime, we need not do this individual multiplications. We can directly multiply 65 and 112. Let us check that. 65 into 112 will give you 7280, same as here. So whenever we have two numbers which are coprime, to find the LCM of it, we just have to multiply it. There is no need to further write one more step of writing this individual factors and the highest power. We need not spend time on it. We can directly multiply the two numbers and get the answer. This is only in the case when the two numbers are coprime. Thus, LCM of coprimes is their direct multiplication. Find the LCM and HCF of 40, 36 and 126. This is a easy problem. We can directly prime factorize all the numbers. 40 is nothing but 2 into 20, and further 2 into 10 and further 2 into 5. Together I can write as 40 is equal to 2 cube into 5. Next 36 is simply 2 into 18 and then 2 into 9 and then 3 into 3. Together 36 equal to 2 square into 3 square. And last we have 126 can be written as 2 into 63 or 3 into 21, further 3 into 7. Together I can write as 126 is equal to 2 into 3 square into 7. Now what will be the HCF of the three numbers, that is 40, 36 and 126. So what are the common factors among all the three? It is simply 2, and the lowest power is in this case, that is 1. So it is simply 2. Therefore the HCF of all the three numbers is simply 2. Now the LCM of all the three numbers, that is 40, 36, 126. We now write all the factors, that are 2 into 3 into 5 into 7, and now we write the highest powers of each factor. So for 2 it is 2 cube, for 3 it is 3 square, and for 5 and 7 it is simply 1, and you calculate, you will get 2520. So LCM of all the three number is 2520. 3 bells ring at intervals of 6, 12 and 18 minutes. If all the 3 bells rang at 6 am, when will they ring together? It is given that at 6 am all the 3 bells rang. And the question is, at what time will they ring again together? All we have to do is calculate the LCM of 6, 12 and 18. Let us start with the prime factorization of all the three numbers, starting with 6. So 6 is basically 2 into 3. So simply 6 is equal to 2 into 3. Next is 12. 12 is simply 2 into 6, and 6 is further 2 into 3, or 12 is 2 square into 3. 18 is 2 into 9, and 9 is 3 into 3. Together 18 is equal to 2 into 3 square. Now we can write the LCM. Let us write all the factors, 2 into 3, and the highest powers of both are 2 square and 3 square, which will come to be 36. So what does this mean? It means that after 36 minutes all the bells will ring together. That is at 6:36 am, that is 36 minutes after 6 am, we have 6:36 am, and at this moment all the three bells will ring together. The largest number which on dividing 1251, 9377 and 15628 leaves remainder 1, 2 and 3 respectively. Let the largest number or the largest divisor of three numbers be denoted as Q. Now we can express all the three numbers as 1251 is equal to A into Q plus 1, because it leaves 1 as the remainder. We need not worry about A. A can be any number. 9377 equal to BQ plus 2 and 15,628 is equal to some CQ plus 3, and we can rewrite all this equation as 1250 is equal to AQ, 9375 is equal to BQ, 15625 is equal to CQ. We have to find the HCF of the three numbers to get Q. Q perfectly divides all the three numbers, leaving no reminders, and that Q will be the largest number that divides the three numbers, leaving these as reminders. Let us prime factorize all the three numbers. So 1250 is 5 into 250. We can write as 5 into 50, that is 5 into 10 and 2 into 5. Similarly, 9375 I can write as 5 into 1875. This will be 5 into 375, 5 into 75, 5 into 15, and this is 5 into 3. And last we have 15,625. This is 5 into 3125, and this is 5 into 625, 5 into 125, 5 into 25, 5 into 5. So in the prime factorized form, 1250 is 2 into 5 power 4, 9375 is 3 into 5 power 5, and 15625 is 5 power 6. So together the HCF of all the three numbers, the common factor is only 5, and the smallest power of the common factor is 4. So it is 5 power 4 or 625. Whenever we are seeing very large numbers ending with 5, simply you start with 5 as the common factor. That's a straightaway procedure. If it is an even number, you can reduce with 2. On a morning walk, 3 persons step out together and their steps measure 30, 36 centimeter and 40 centimeter. What is the minimum distance each should walk so that each can cover the same distance in complete steps? So in this problem, what we have to find is basically the LCM of 30, 36 and 40. That will give the answer for the minimum distance that each of the 3 persons should walk so that they cover the same distance in complete steps. LCM of 30, 36 and 40. So 30 is simply 2 into 15 and 15 is 3 into 5, or 30 is equal to 2 into 3 into 5. 36 I can write as 2 into 18, and this is 3 into 6, and this is 3 into 2. Therefore 36 is 2 square into 3 square, and 40 2 into 20, and 2 into 10, and this is 2 into 5. So 40 is 2 cube into 5. So to write the LCM, I have to write all the factors available, that is 2 into 3 into 5, and the highest power of 2 is 3. For 3 it is 2, and for 5 it is 1, and you calculate, you will get 8 into 9 into 5, or 360 centimeter. Have all of you understood this problem from a physical sense? For those of you who could not understand what this problem actually means, I will show you a physical description of what is meant or what is asked in the given question. This image is not exactly to the scale, but this is only for all of you to have an understanding of what is being asked in the problem. On a morning walk, 3 persons step out together, and their steps measure 30, 36 and 40 centimeter. So let the first person be A, and second person be B, and third be C. Okay, one in the red has the shortest step, so this is 30 centimeter, and the second one, the blue, he has 36, and the green has 40. Okay, you can see that in terms of step size, so this is the smallest one, and 36 is slightly larger, and 40 is slightly even bigger. So each complete step means this is one complete step for person C. So he has another complete step, like that. For person A, which has the shortest step, his complete step is even smaller. Okay, so all of them started their walk at some point here. Okay, so this is the starting reference, and they all started from this reference, and in this direction they are walking, and after walking some distance, let's say they reached here, all the 3 persons reached here, and they reached here in complete step. The person C made his complete step and he exactly reached here. Similarly, the second person B, with his complete step, he reached here, and with this complete step, person A also reached here. Let us say we are looking at some point here. Okay, now what happens? For person C, he made 2 complete steps. Okay, but for person B, his third step, he is actually in the middle of the third step. If he makes one full step, he will be outside this position. What we need is some distance from the starting line, and at that distance all the 3 persons should complete his complete steps together. In this problem, when we calculate the LCM of 30, 36 and 40, we got that to be 360 centimeter. So this is the 360 centimeter. It starts from the reference, and it took 360 centimeter, and after 360 centimeter, all the 3 persons would have completed or would have reached this point with complete steps. One more variation can be asked in the same question, that is how many steps each of the 3 persons would have to make so that they cover the same distance in complete steps. Okay, so what we have to do here, at 360 centimeter, we observe that all the 3 persons will complete the distance in complete steps. So we just have to calculate the number of steps they would take, and that would be simply 12 steps for person A and 10 steps for person B and 9 stems for person C. A rectangular courtyard is 18 meter 72 centimeter long and 13 meter 20 centimeter broad. It is to be paved with square tiles of same size. Find the least possible number of such tiles. The first thing that we can do is that the length and the width of the courtyard is given in a combination of meters and centimeter. So let us convert everything into centimeter. So 18 meter 72 centimeter is simply 18 into 100 centimeter plus 72 centimeter, or 1872 centimeter. Similarly, 13 meter and 20 centimeter is simply 13 into 10 centimeter plus 20 centimeter, and together 1320 centimeter. We have the length and the width of the rectangular courtyard, and we have to find the least possible number of tiles that will fit this courtyard. Let us calculate the total area of this courtyard. So let the total area of the courtyard be denoted by the letter A, and that will be A equal to 1872 into 1320. We do not know the size of the tile, but it is given that it has to be a square tile. So let the side of the square tile be x, okay, and the number of tiles that are required to fill the courtyard, let us denote as n. So how can we relate this, the total area of the courtyard, to x and n? We can write area A is equal to 1872 into 1320 is equal to the area of one single tile, that will be x square, into the number of tiles. This is the equation which relates the total area to the size of one single tile and the number of such tiles which can fill this entire courtyard. How do we solve this? The thing that we have to imagine or understand is that the length of the square tile x, it has to be in such a way that it perfectly divides both the length and the width of the rectangular courtyard. Only if the size of the square tile perfectly divides the length and the width, we will be able to perfectly fit the courtyard with the rectangular tiles. Otherwise, we will have to cut some of the square tile like we actually do in our actual homes and buildings. This calculation is not done. We will start with some square tile that we like, and in most of the scenarios it will not perfectly fit our rooms or buildings, and the laborer will be cutting some of the square tiles so that it fits the carpet area. But in this problem, we have to find the size of the tile in such a way that it will perfectly fit the courtyard, and there is no scenario of cutting a tile. We do not make any cuts or modifications to the tiles. We just take the tile as it is and we will fill the courtyard. And that can only be possible if the size of the tile perfectly divides both the length and the width of the courtyard. And the second requirement is that the number of tiles that is required has to be the least. So we have to match two requirements. One is we should not make any modifications or cuts to the square tiles. Second, we have to use the least possible number of such tiles. Once more I will repeat, the side x of the square tile has to be in such a way that it perfectly divides, okay, it perfectly divides the length and the width of the rectangular courtyard. We have to find the highest divisor of the length and width of rectangular courtyard, or we have to find the HCF of the length and width of the courtyard. So let us prime factorize both the dimensions, starting with 1872, and that is 2 into 936, and this is 2 into 468, and this is 2 into 234, this is 2 into 117, this is 2 into 3 into 39, and 3 into 13. Similarly, 1320, I can write 2 into 660 and 2 into 330. This is 2 into 165. This is 5 into 33, and this is 3 into 11. So together I can write 1872 is simply 2 power 4 into 3 square into 13, and 1320 is 2 cube into 3 into 5 into 11. So what will be the HCF of 1872 and 1320? It will be simply 2 cube into 3, because 2 and 3 are the only common factors that we have, and their lowest powers are 3 and 1. So this is nothing but 24 centimeter. Okay. Now we have this 24 centimeter that we have to substitute in this equation. Once again, what is this 24 centimeter? This 24 centimeter is nothing but the value of x, which is the side of the square tile. So I'll come back here. I will substitute the value of x square in this equation. So that will be 24 square into n. And you have to calculate yourself. You will get n as how much? 4290. So 4290 tiles is required to fill the courtyard, so that we do not make any cuts to the tiles, and also this is the least amount of tiles that is required. Find the greatest number of 6 digits exactly divisible by 24, 15 and 36. How do we solve this problem? We have to find the greatest number of 6 digits, and that should be exactly divisible by 24, 15 and 36. So we can understand that whatever number that we need to find, it will be a multiple of 24, 15 and 36. So the procedure will be, first we will find the lowest common multiple of the three numbers, that is LCM of 24, 15 and 36. And once we find the LCM, the multiple of that LCM we have to check to get the greatest number of 6 digits in length. So we will go step by step. We'll start with the LCM of the three numbers. 24 is simply 2 into 12 or 3 into 2 square. So 24 is 2 cube into 3. 15 is simply 3 into 5. So 15 is 3 into 5. And lastly 36 is 2 into 18, and this is 2 into 9 or 3 into 3. So 36 is 2 square into 3 square. So the LCM of all the three numbers will be, let us write all the factors, 2 into 3 into 5, and the highest factors are 2 cube, 3 square into 5 power 1, and the value will be 360. Okay, now we have to find multiples of 360 till it gets to the largest 6-digit number that will be divisible by 24, 15 and 36. So when we find the LCM of the three numbers, we got 36. What it means is that any multiples of 360 will always be divisible by 24, 15 and 36. Now we have to find the largest 6-digit number that will be divisible by 24, 15 and 36. For that we just have to find that multiple of 360 which is as high as possible. To do this, what we have to do? What is the largest 6-digit number? The largest 6-digit number is 9,99,999. Now what we need is the largest 6-digit number which is a multiple of 360. For that what we can do is that we can divide this number by 360. We will do our usual division. So it is a straightforward process. Moving further, you will get 2520 and you will get the same remainder, and you have to do again. So this becomes a repeating scenario. So this will just go on. The division process will never end. It will continuously go on. So we will have this value also continuously going in. From this process, what we can understand, if I multiply 360 with 2777, I will get the largest 6-digit number that is divisible by the three numbers. So what I have to do is that 360 into 277, I will get 9,99,720. This is the largest 6-digit number that is perfectly divisible by 24, 15 and 36. Prove that 5 plus root 3 is an irrational number. To solve this, we can use the method of contradiction. We will start with the assumption that 5 plus root 3 is a rational number, and therefore we can write 5 plus root 3 as p by q, where p and q are integers and q is not equal to 0. So we can rearrange as 5 minus p by q is equal to root 3, and I can do some simple modifications. It will become 5q minus p whole divided by q is equal to root 3. But we know that p and q are integers, so definitely 5q minus p by q, this will definitely be an rational number. But on the other side we have root 3, which we definitely know is a irrational number. on the left hand side we have a number phi q minus p by q, and this p and q are integers, and therefore phi q minus p by q, it will definitely be a rational number. On the right hand side we have root 3, okay, and we know that root 3 is an irrational number, and therefore it goes against our initial assumption that 5 plus root 3 is rational, or simply the answer is that 5 plus root 3 is a irrational number. Prove that root 11 plus root 17 is irrational. So let us assume that root 11 plus root 17 is a rational number. So we can write root 11 plus root 17 is equal to p by q, where p and q are integers and they are in the smallest form, okay. So I can rearrange this as root 17 minus p by q is equal to minus root 11, okay. Now what I do is that I square both the sides. So I'm going to square this side and I'm going to square this side. Now I can write 17 plus p square minus q square minus 2 root 17 p by q is equal to 11, or I will isolate this root 17, okay. So I can write 6 plus p square by q square is equal to 2 root 17 p by q. In other words, this is going to be 6 q square plus p square divided by 2 pq equal to root 17. Now we know that root 17 is definitely going to be a irrational number. Why? Because this is square root of a prime number. For any prime number p, root p will be a irrational number. And on the left hand side we have a term using p and q, and we started this problem with the assumption that p and q are integers. So this is definitely going to be a rational number, but on the right hand side we have an irrational number, and this cannot match, and it shows that our original assumption of root 11 plus root 17 is a rational number is wrong. We move to the next question. Show that there is no positive integer n for which root n minus 1 plus root n plus 1 is rational. So we proceed in a similar way to the previous question. That is, we assume that for some positive integer n, root n minus 1 plus root n plus 1 is a rational number. Then we can write this as, let a by b is equal to root n minus 1 plus root n plus 1. And what I will do, I will take square of both the side, and this particular term, if I square, it will be of the form a plus b square. So a square by b square is equal to n minus 1 plus n plus 1 plus 2 into root of n minus 1 into root of n plus 1. This is nothing but a square by b square is equal to 2n plus 2 into square root of n minus 1 into square root of n plus 1. Now what I will do is that in this particular equation we have the two terms, and for n plus 1 I will take this equation, isolate n plus 1 and substitute back in this equation, okay. So we have our original equation, and I will take square root of n plus 1 is equal to a by b minus square root of n minus 1, okay. So I have this equation, this I am going to substitute here, okay. On substitution I will get a square by b square is equal to 2n plus 2 into root of n minus 1, and this is going to be a by b minus root of n minus 1. And now I will expand the terms, so it is 2n plus 2a by b, the square root of n minus 1 minus 2 into n minus 1. Now this will come to be 2a by b square root of n minus 1 plus 2, and this side is a square by b square. How? Because this 2n and this 2n will get cancelled out. Now I will isolate root n minus 1 from this equation. A square by b square minus 2 is equal to 2a by b root of n minus 1, or a square by 2b square by 2ab is equal to root of n minus 1. Thus we have found an expression for root n minus 1 in terms of a and b. Now that I have found an expression for root n minus 1 in terms of a and b, I can substitute this in this equation and I can get an expression for root n plus 1. Let me do that. I will get root n plus 1 is equal to a by b minus a square minus 2b square by 2ab, and I will put this in bracket. Okay, this will come to be a by b minus a square plus 2b square by 2ab, or a square plus 2b square by 2ab. Okay, so now I have got an expression for root n plus 1 also in terms of a and b. Okay, so we have one expression for root n minus 1 and we have another expression for root n plus 1, and what we have to do in this question, we need a sum of this term and this term, and we have to check whether that is a rational number. To do this, we can analyze this particular part and this particular part. Once more, these two terms which are same as this, these are going to be definitely a rational number. Why? Because a and b are integers, but we are doubtful about these two terms. Okay, now when can these two rational numbers, that is these two rational numbers, be same as this? This can only happen when this one and this one are perfect square. That is, these two equations, they are going to be correct. That is, these two sides match and these two sides match, and this can only match, and this is only possible if this n minus 1 and n plus 1 are perfect square. Okay, when n plus 1 and n minus 1 are perfect square, then we will be able to find a square root here and here, and that square root will be a rational number and it will match the other side of the equation. Okay, now what we have to see is that when can n minus 1 and n plus 1 become a perfect square. So how can I check that n minus 1 and n plus 1 for some positive integer n will always become a perfect square? So let us check what will be the gap between these two numbers. N plus 1 minus n minus 1, you will get 2. Okay, that is, a gap of 2 exists between n plus 1 and n minus 1 for any positive integer n, or it means that with a gap of 2 we have to find two perfect square. Once more I will repeat, we have to find two numbers within a gap of 2 and it has to be a perfect square. Okay, now let us check that what kind of numbers will form a perfect square and what are the gaps between any two potential perfect squares. So what is a list of positive integers? They are simply 1, 2, 3, 4, 5, 6 and so on. And what will be the squares of all these numbers? It will be again 1, 4, 9, 16, 25, 36 and so on. So let us check what is the gap between two consecutive perfect squares. Okay, these are nothing but perfect squares, right? So let us check what are the gap between two consecutive perfect squares. So 4 minus 1 is going to be 3, 9 minus 4 is going to be 5, 16 minus 9 it's going to be 7, 25 minus 16 it's going to be 9, 36 minus 25 it's going to be 11 and it will continue. What we can observe here is that the gaps 3, 5, 7 it is always increasing in value, right? It is never going to decrease in value and the smallest that we have is 3 and that comes for these two perfect square, that is 1 and 4. So for two consecutive perfect square the least gap possible is 3. Once more, for two consecutive perfect squares or for any two perfect square the least gap that is possible is 3. You take any other two perfect square, the gap will be always more than 3. And in this question we have to find two numbers within a gap of 2 and those two numbers has to be a perfect square. So is it possible? The overall answer is no. The conclusion is the minimum gap possible between two perfect square is 3, which is for 1 and 4, and in this problem we have to find two perfect square within a gap of 2, okay, that we found out here. Thus there is no positive integer n for which root n minus 1 plus root n plus 1 will become a rational number. Next question is prove that 2 minus root 3 by 5 is an irrational number given that root 3 is an irrational number. In this question it is already provided that root 3 is irrational. So we have to make use of that knowledge. So let a and b be any two integers and we are going to assume that 2 minus root 3 by 5 is equal to a by b is a rational number. So I can rearrange this as 2 minus root 3 is equal to 5a by b. I will isolate root 3. So root 3 is 2 minus 5a by b. Now it is given in the problem that root 3 is an irrational number. And on the RHS we have 2 minus 5a by b and a and b are integers. So definitely this whole term will be a rational number. I will repeat, 2 minus 5a by b is going to be a rational number and we also know that root 3 is a irrational number. Hence this is a contradiction. or it means that the initial assumption that we took is wrong and 2 minus root 3 by 5 is a irrational number. Prove that for any prime positive integer p, root p is irrational. So let us consider any positive prime integer p and let us assume that root p is a rational number. So we can write root p is equal to a by b, where a, b together form a coprime. That means a by b is in its smallest form, or there are no common factors between a and b other than 1. Let us square both the sides. Squaring both sides, we will get p is equal to a square by b square, or b square p is equal to a square, and so we can write p divides a square. Why? We have multiplication of two numbers resulting in a square. That means p is a factor of a square, or p divides a square. And if p divides a square, it also means that p divides a. So you may have a confusion how this has come. So we have a theorem that p be a prime number, and in this problem we have considered p as a prime number. It is given in the question. So let p be a prime number and a be a positive integer. If p divides a square, then p divides a. So we have used this theorem to write this part. Okay. So now I can write a is equal to p into c for some integer c. Now what I will do is that I will take a equal to pc and I will substitute here. b square p is equal to a square is equal to pc whole square is equal to p square c square, or b square is equal to p c square. And what does this mean? It means that p divides p square and p divides b. We have applied the same theorem as stated before, and now I can write b as b is equal to p into d for some integer d. So together we have one statement that p divides a and second statement as p divides b. So together we have p divides a and p divides b. So what does this mean? This means that p is a common factor of a and b. Okay. And this is against the original assumption of a and b are coprimes. We started the problem that a and b are coprimes, right? That means there is no common factor between a and b other than 1. But through this problem, as we did, we observed that p divides a and p divides b, so p should be a common factor of a and b, and this violates our original assumption. So in nutshell, root p is irrational. If the prime factorization of a natural number n is 2 cube into 3 square into 5 square into 7, write the number of consecutive zeros in n. So we have the given number n is equal to 2 cube into 3 square into 5 square into 7, and these factors I can rearrange as 2 into 3 square into 7 into 2 into 5, I write it as whole square, okay, or n is equal to 2 into 3 square into 7 into 5 into 2 and square of it, we will get 100. The value of n, that is 2 into 3 square into 7. Whatever this number is going to come, this will end with some digit other than 0. And we are multiplying this whole answer with 100. That means the overall value of n will end with 2 zeros, or the number of consecutive zeros in this number n will become 2. A and B are relatively prime numbers. Then what is their HCF and LCM? And we have 4 options given. Please take a moment to go through it. So it is given in the problem that A and B are relatively prime numbers. Okay, that means there is no common factor between A and B other than 1. So what will be the HCF of A and B? HCF of A and B is nothing but the highest common factor between A and B, and that is simply going to be 1. Okay, because A and B are co-prime. And what about the LCM? LCM between A and B is going to be the direct multiplication of the two numbers A and B. Now when you look at the options, you will see that option C matches this answer. Let us move to the next question. If A and B are prime numbers, then what is their HCF and LCM? Again, please take a moment to go through the options. So how do we solve this? It is very simple. It is as same as the previous problem. Here A and B are prime numbers. That means there are no common factors between A and B, or the HCF of A and B is simply going to be the 1, and LCM of A and B is going to be the direct multiplication. So the answer is as same as in the previous problem. HCF is 1, LCM is AB, and it is going to be option 3rd. If P, Q are prime positive integers, prove that root P plus root Q is an irrational number. So let us write root P plus root Q equal to A by B, and AB form a coprime. Okay, what I will do here is I will square both sides. Okay, and I will write P plus Q plus 2 into root P into root Q equal to A square by B square. Rearranging, I will get P plus Q minus A square by B square is equal to minus 2 into root P into root Q. Now what I will do is that I will isolate root P from this equation and I will substitute here. I will get root P is equal to A by B minus root Q, and now I will substitute the value of root P in this equation. I will get P plus Q minus A square by B square is equal to minus 2 root Q into A by B minus root Q. I can expand this side. It will be minus 2A by B into root Q plus 2Q, and on this side I have P plus Q minus A square by B square. Now I will rearrange the terms. I will get P minus Q minus A square by B square is equal to minus 2A by B into root Q. Further, if I rearrange, I will get root Q is equal to PB minus QB minus A square divided by minus 2A into B. Sorry, it will become B square. So it is given in the problem that P and Q are prime integers, or square root of Q is going to be an irrational number. Fine. And on this side we have an expression in terms of A, B, P and Q, and all these are integers, that is a, b, p, q are integers, and together this forms a rational number. And this is not possible, right? We cannot have an irrational equating to a rational number. Once more, square root of a prime number is always going to be irrational, and on the RHS we have a fraction using integers a, b, p and q, that is this term, and this RHS is always going to be rational, so we have a mismatch here. And in this problem, one more approach to think is that we need not do all this exercise. We have root p plus root q as the question asked, and we can straight away say that p and q are prime integers, so definitely square root of a prime number is always going to be irrational, and we know that sum of any two positive irrational numbers, in this case root p plus root q, will always result in a irrational number. Let p be a prime number. The quadratic equation having its factors as 0 is, so we have a prime number p and we also have a quadratic equation. The question is that we will have some solutions for the given quadratic equation, and those solutions has to be the factors of the prime number. So for any prime number, what are its factors? Factors of any prime number p, it will be always number 1 and the number itself, right? So how can we write the quadratic equation? We have to write a quadratic equation whose solutions will be same as these two numbers, and these two numbers are factors of the prime number p. So I can write this as x minus p into x minus 1 is equal to 0. So expanding, you will get x square minus px minus x plus p is equal to 0, or x square minus p plus 1 into x plus p is equal to 0, and this will be same as option B. Let n be a natural number, then the LCM of n and n plus 1 is, we have 4 options. How can we solve this? In this case, I will straight away write the answer. The answer will be n into n plus 1, that is option C. Why? It's given that n is a natural number, okay? So for any natural number, the numbers n and n plus 1 will be coprime. You take any natural number n, then that number n and the next number n plus 1 will always form a coprime. So let us look a bit more deep into this. You take any number, okay? Take any number. What are the smallest factors possible for it? The smallest factors could be 1, okay? It can be 2. We don't know the number n, but it can be 2. It can be 3, okay? And the next prime number is 5, okay? It can be 7, and so on. Fine. Let us assume that 2 is the factor, 2 is the smallest factor for the number n, okay? Now what will be the next smallest number such that 2 will be the factor? That will be n plus 2, okay? Let us take one more example, and this time let us assume that 3 is the smallest factor for the given number n, okay? Then what will be the next smallest number which is having 3 as the factor? That will be n plus 3, okay? In the given problem, we have two numbers n and n plus 1, and we just saw that if 2 is the smallest factor, then after n it has to be n plus 2, which is not the case here. Similarly, for the given two numbers, let us assume 3 is the smallest factor, then after n, the next value has to be n plus 3, but we have n plus 1. That means that 1 is the common factor for n and n plus 1, or n and n plus 1 will always form a coprime. Clear? In the given question, we were asked what is the LCM of n and n plus 1, and that is going to be n into n plus 1, or the direct multiplication of n and n plus 1. What will be the HCF of n and n plus 1? The HCF of n and n plus 1 will come to be simply 1. If 3 is the least prime factor of m and 5 is the least prime factor of n, then the least prime factor of m plus n is, we have 4 options: 11, 2, 3 and 5. In this problem, we can write m as a number, and it is given that when it is prime factorized, 3 is the least prime factor. So we can write m is equal to 3 into some numbers. Okay. Similarly, n, it's given that 5 is the least prime factor. So I can write n is equal to 5 into some numbers. So whatever be this number, okay, we do not know the other set of numbers. Similarly for n, we do not know the other set of numbers. But irrespective of whatever these numbers are, we are multiplying this number with the value of 3 for m, and we are multiplying this number with 5 for n. That means m is an odd number. Why? Because we are multiplying it by 3. Similarly, n is also an odd number. Why? Because we are multiplying by 5. So what will happen if we add two odd numbers? It is going to be an even number. Now before we move ahead, some of you may have a confusion that how can we say that for a number m which can be written as 3 into something, it can always be odd. 6 is a multiple of 3 and that is not an odd number, that will be an even number. Then how can we write this? The thing that you have to understand is that it is given that 3 is the smallest prime factor for m. That means 2 doesn't exist in this prime factorization. Okay. If 2 was there, then there is a chance of m becoming an even number. But in this problem, 3 is the smallest factor for m. That means m will always be an odd number. In the case of 5, we have the same thought process. One of the first prime number that you can think of when we look at the multiples of 5 is 5 into 2 is 10. 5 into 2 is 10 and 10 is an even number. But again, 5 is the smallest prime factor for the given number n. That means whatever this number is, it will always be a odd. So in summary, m plus n will always be an even number, and for an even number 2 will be the least prime factor. Okay, so the answer to the given question is 2. N square minus 1 is divisible by 8 if n is option A an integer, option B a natural number, option C an odd number, option D an even integer. So it's given that n square minus 1 is divisible by 8. So we can write n square minus 1, this will be a even number. Why? Because n square minus 1 is divisible by 8, and if it is divisible by 8, it means it is an even number. Further, this means that n square will be a odd number. Why? Because we have removed 1 from n square minus 1. Further, we can understand that n will be a odd number. Why? You take any perfect square which is an odd number. the square root of that will be always an odd number. Once more I will repeat. If a perfect square is an odd number, okay, then the square root of that particular number will always be odd. If we have some doubt, let us check some examples. What is 9? It's a perfect square, and what will be the square root of it? It will be 3. Let us look at another perfect square which is odd, 81. Okay, what will be the square root of it? It will be simply 9. One more example, 121. It's a perfect square and it is an odd number, and the square root will be simply 11. Again an odd number. We have a odd perfect square giving a odd square root. We have a odd perfect square giving a odd square root. We have a odd perfect square giving a odd square root. So the answer will be option C, an odd integer. Root 5 plus root 3 plus 2 is we have 4 options. This is a simple question. We are adding two irrational numbers with a rational number. Okay, so definitely this is not going to be a rational number. Why? So what will be the answer? It will always be irrational. So the answer is option D, an irrational number. If you are adding an irrational number with a rational number, it will always be irrational. Okay. Further to keep in mind is that adding any two positive irrational will always result in an irrational number. Note, it has to be two positive irrational. We can have a case that root 2 minus root 2 is equal to 0, and that is a rational number. Okay, so it has to be addition of two positive irrational numbers. If n is equal to 2 cube into 3 power 4 into 5 power 4 into 7, then the number of consecutive zeros in n is, where n is a natural number. We have already solved a similar problem earlier. I will quickly go through this. So n can be written as n is equal to 2 cube into 5 cube into 3 power 4 into 5 into 7. This is nothing but n is equal to 1000. Why? 2 cube into 5 cube will give 1000 into 3 power 4 into 5 into 7. Further, 1000 into 3 power 4 into 7 into 5. I'll put this in brackets. This value, that is 3 power 4 into 7 multiplied by 5. So we have an odd number multiplied by 5. That means this whole number will end with the digit 5 multiplied by 1000. That means altogether n will be having 3 consecutive zeros. So the option is 3 or option B. The total number of factors of a prime number is, we have 4 options, 1, 0, 2 and 3. In a rush, most of you will opt for option A, that is 1, but it is wrong. In the rush of the exam, you will be in tension mode. A lot of you may take the option A, that is 1, but this is wrong. Why? Let P be a prime number, then its factors are 1 and P. That means we have 2 factors. Okay. And therefore option C, 2 is the correct answer. If A equal to 2 cube into 3, B is equal to 2 into 3 into 5, C is equal to 3 power n into 5, then the LCM of A, B, C is given as 2 cube into 3 square into 5. Then the value of n is, we have 4 options. We can write LCM of A, B, C is equal to, let us write all the factors of all the numbers. That is going to be 2 into 3 into 5. And the highest powers, for 2 it is going to be 3, for 3 it could be 1 or n, and we will assume that n is greater than 1, so n, and for 5 it is going to be 1, and this is equal to 2 cube into 3 square into 5. This means that n is equal to 2. It's a simple problem. Option B will be the correct answer. 119 square minus 11 square is we have 4 options: prime number, a composite number, a odd prime number, and fourth option is an odd composite number. At first glance you can see that option A and option C are funny. Why? Because all prime numbers are going to be odd except for number 2. Nevertheless, we can write 119 square minus 11 square. Let us write like this. 119 square will become some number and it will end with 1 for sure. Minus 11 square will end with another number and that will also end with 1. Okay. So what will be the overall answer? Any doubt here? 119 square, if I take the actual value, it will end with the digit 1. Why? We have 9 here, and that means 9 square is 81, and this number will end with the digit 1. Similarly, 11 square, this number, it will end with the digit 1. Why? Because 1 square is going to give 1 and that will come here. So when we subtract 11 square from 119 square, like we are doing here, we will get a value as 0 and some number. So this number will end with the digit 0. That means it is going to be a even number. So option A and C are going to be wrong because it is not a prime number, and option D is wrong because it is not an odd number. The final answer is option B, a composite number. If the LCM of two prime number P and Q, P greater than Q is 221, then the value of 3P minus Q is, we have 4 options: 4, 28, 38 and 48. How do we solve this? It's given that LCM of PQ is equal to 221, and it's given that P and Q are prime numbers. That means 221 is equal to simply PQ. That is the direct multiplication of the two numbers. Why? Because P and Q are prime numbers. So the question is, what will be the value of 3P minus Q? In this problem, 221 is relatively a small number and it is a result of a product of two prime numbers. So we can quickly think of two prime numbers such that if I multiply P and Q, it should get 221. So what we can do here is that we can think of the values of P and Q such that when I multiply PQ, it will end up with some number and having 1 as the last digit. So what are some possibilities? So it could be something like PQ is equal to some value P, maybe 3 is the last digit of P and 7 is the last digit of Q, and this can end with some number ending with 1. Okay, you can quickly try some numbers for P and Q, that is some prime numbers P and Q which is ending with 3 and 7, so that we have 1 as the last digit of its multiplied value. And when you try, you will get PQ is equal to 13 into 17, and it's given that P is greater than Q, so P has to be 17 and Q has to be 13. Therefore 3P minus Q is equal to 3 into 17 minus 13, and that value is 38. So the answer is option C, 38. If 3 is the least prime factor of a number A and 7 is the least prime factor of number B, then the least prime factor of A plus B is, we have solved a similar problem before. anyway I'll go through this quickly. So A is given as some number with 3 as the smallest prime factor, and for B it's given as 7 is the smallest prime factor. This means that A will always be a odd number. Why? Because 3 is the smallest factor of A. Similarly, B will always be a odd number. Why? Because 7 is the smallest prime factor for B, and all other prime factors are going to be odd. So when we multiply one odd with another odd number, it will always be a odd number. The same logic can be applied here once more. 3 is the smallest prime factor of A, and all other prime factors are always going to be an odd number. So when I multiply one odd number with another odd number, it will always be a odd number. And when you add two odd numbers, it will always be a even number. Or for all even numbers, 2 will be the smallest prime factor. That means option A, 2 is the answer. A pair of irrational numbers whose product is a rational number is, we are given 4 options. We will go through one by one. The first option is root 16 and root 4, and so we can write root 16 into root 4. This is equal to 4 into 2 is equal to 8. This is a rational number and this is a rational number. That means we are multiplying two rational numbers, and option A is not the one we need. We move to option B, root 5 into root 2, and that will be square root of 10. Now this is going to be an irrational number, and root 2 is also an irrational number, and square root of 10 is also going to be a irrational number. So option B is also not correct. Option C is root 3 into root 27, and this is equal to root 3 into, this I can write as 3 into 3 into 3, or root 3 into 3 root 3, or this is going to be, so in this process when we look at option C, we have the two numbers going to be irrational in nature and the multiplied value is a rational number. So for the given question, the correct answer is option any C. One of the numbers a plus 2 and a plus 4 is a multiple of, we have four options, 2, 3, 5 and 7. Have all of you understood this question very clearly? So we have three numbers a plus 2 and a plus 4, and any one of these numbers has to be a multiple of either 2 or 3 or 5 or 7. So let us understand the question clearly. Okay, so we have the numbers a plus 2 and a plus 4. Okay, let us understand the question clearly. If option A, that is 2, okay, if 2 can divide any of these numbers, okay, then that is a correct answer. Once more, let's assume that option 3 is the correct answer. That means 3 will be able to divide either a or a plus 2 or a plus 4. Similarly for 5 and 7. Once more I will repeat. Let us assume that option A is the correct answer, that is 2. Okay, this means that the 2 will divide any of the three given numbers. The three given number are these three. So 2 will divide any one of these numbers. We don't know which one, but any one of them. Similarly, let us assume that option B is the correct answer, that is 3. That means 3 will divide any of these three numbers. We don't know which one, but any one of this. Now how can we solve this? We will go option by option, starting with 2. If you divide any number by 2, Okay, we have two possibilities for the remainder. What are those? 0 and 1. If 2 perfectly divides a number, the remainder will be 0, right? And if 2 imperfectly divides a number, that means the number is an odd number, then the remainder will be 1. First, let us look at a case when 2 perfectly divides a. Okay, then what will be the remainder in each of the scenarios? So if 2 perfectly divides a, then remainder for the given number a will become 0. For a plus 2 again, the remainder will be 0. For a plus 4 again, the remainder will be 0. Why? Because 2 perfectly divides a, that means 2 is an even number, right? And a plus 2 and a plus 4 will also be an even number. So if 2 perfectly divides a, we have remainder equal to 0, and we have the same remainder in both cases. Now we look at the second scenario. 2 imperfectly divides a. Okay, in this case the remainder will be 1 for number a, and for a plus 2 again it will be 1, and a plus 4 again it will be 1. Why? Because when we divide a by 2, it is an imperfect division, so we have remainder 1. That means a is a odd number. If a is a odd number, then a plus 2 also will be an odd number, and a plus 4 also will be a odd number, and we will have the same remainder. So with respect to 2, we have only two remainders possible, r equal to 0 and r equal to 1. And in scenario 1, we see that all the numbers are perfectly divided by 2, leaving 0 as the remainder. So any of the number is a multiple of 2. And in the second scenario, we have a remainder as 1 for all the three numbers. That means none of these three numbers are a multiple of 2. That means we do not follow the given criteria of the question, that is any one of these numbers should be divisible by 2. That is not possible because the remainder is 1. Therefore option A2 is not the correct answer. Okay, now we'll go to the second option 3 and we will check. Now the second case, if you divide the number by 3, okay, we will have 3 possibilities for remainder, that is 0, 1 and 2. If you divide any number by 3, okay, then we will have 3 possibilities for remainder, that are 0, 1 and 2. So we have 3 scenarios. If 3 perfectly divides a number, and the remainder will be 0. If 3 imperfectly divides, okay, then we have 2 scenarios, r equal to 1 or r equal to 2. Now let us look at the case with 3. So we start with the assumption that 3 perfectly divides a. Okay, if 3 perfectly divides a, what will be the remainder? R will be equal to 0. And then what will be the scenario of a plus 2? The remainder will be 2. And for a plus 4, remainder will be 1. The second case, we look at the second case, 3 imperfectly divides a, and let us assume that in the imperfection case r equal to 1 or the remainder is 1. If a divided by 3 is resulting a remainder of 1, what will be the case when a plus 2 is divided by 3 and a plus 4 is divided by 3? The remainders will be 0 and 2. Now the last case, again 3 imperfectly divides a, and we already checked one possibility of remainder. Now we will check the second possibility, that is r equal to 2. Okay, now when we divide the number a by 3, we got the remainder 2. Then what will be the remainder when we divide a plus 2 and a plus 4 by 3? We will get r equal to 1 and r equal to 0. Now look clearly, we checked all the 3 cases and we see that in each of this case we have a number that is perfectly divided by 3. Okay, and here we have a case. Once more I will repeat, we checked all the 3 cases of having remainders 0, 1 and 2, and we see that in each of the case there is at least one number that is perfectly divisible by 3. Okay, so in all the cases we have a number that is perfectly divisible by 3. Therefore, option B 3 is the correct answer. Some of you may have a doubt that why we only considered 3 perfectly divides A, right? We didn't consider 3 perfectly divides A plus 2 or 3 perfectly divides A plus 4. Okay, I will ask all of you having these doubt to try the same exercise. Instead of A, you try A plus 2, and then instead of A, you try A plus 4. That is 3 perfectly divides A plus 2. Okay, then you try 3 imperfectly divides A plus 2, and then you check 3 imperfectly divides A plus 2, check both the cases of reminders. You will eventually get into the same possibilities. Okay, consider the following frequency distribution of the heights of 60 students of a class. The sum of the lower limit of the model class and the upper limit of the median class is. So we have the marks distribution given starting from 150 to 180. The first thing about the model class, it is simply the class with the highest frequency, and that will be 150 to 155. Now we have to find the median class. For that we will write the cumulative frequency. I will denote as CF. First one will be same as 15. Next will be 15 plus 13, it will be 28, and then 28 plus 10, 38. 38 plus 8, it is going to be 46. 46 plus 9, it will be 55, and 55 plus 5, it is going to be 60. We can also write summation of all this value is going to come as 60. This is going to be same as this. Therefore we have n as 60, or n by 2, which is the midpoint, will be 30. So where will be the 30th value? 30th value will be between 28 and 38. Therefore 160 to 165 will be the median class. Now the question asked is that sum of the lower limit of the model class and the upper limit of the median class. So that will be 150 plus 165. And that value will come to be 315. That is option B. If xi's are the midpoints of the class intervals of grouped data, fi's are the corresponding frequencies, and x bar is the mean, then fi xi minus x bar is equal to, and we have 4 options. What I understand is that the question is not clearly given. Okay, when I try to solve this, I personally feel that there is some issue with the way the question is represented. In the question we are asked to find fi xi minus x bar. Now there is no doubt about fi xi. It is a summation of all the fi xi values. Okay, and x bar is the mean. But what will be the value together? That we cannot find, right, without the actual values. Let's write the equation for the mean, that is x bar, and we will get x bar equal to summation fi xi divided by summation fi. Okay, or I can write summation fi multiplied by x bar is equal to summation fi xi. Okay, so further I can write 0 is equal to, by rearranging the terms, summation fi xi minus summation fi x bar, or 0 is equal to, removing the summation notation, I can simply write fi xi minus fi x bar. You can see that fi xi minus fi x bar will come to be 0. In the question we are asked fi xi minus x bar. Now what will this value come to be? I simply do not know. Okay, if the question was fi xi minus fi x bar, then it will be 0. If you look at the answer provided by CBSE for this question, it is given as 0. So I think there is a printing mistake where they have missed this fi in this question. Okay, I think what they meant is fi xi minus fi x bar, and they missed this fi x bar. In the formula, x bar equal to a plus h into fi ui divided by fi, for finding the mean of the grouped frequency distribution, ui is given as, it's a straightforward problem. We are asked to find the value of ui, that means this is coming from step deviation method, and ui will be simply equal to xi minus a by h, and that will be option C. The abscissa of the point of the intersection of the less than type and of more than type cumulative frequency curves of a grouped data gives its, we have 4 options: mean, medium, mode, and all of the data. To solve this, what I have done is that I have used data already available in the CBSE textbook, that is in chapter statistics, particularly table 13.13 and table 13.14. So I have taken values from these two tables and made a plot. Okay, because making this plot is very important for all of us to have a feeling of, or to understand what is this problem actually. So this is the plot. Okay, again the values are from the table 13.13 and 13.14. Okay, you can refer to these tables for these data points. Okay, so the points in the rose color that you see here, that is the less than type, and the points in the blue color is the more than type. Okay, I will not go into the details of how this is plotted, but I will give few examples. Let's say we are plotting the first point from the less than type frequency curve. So the first point is marks obtained less than 10. Okay, we have 5 students, right? So less than 10 is this area and we have 5 students. Okay, and the last point is marks obtained less than 100, we have 53 students, and that is this point. Okay, if we show here, it will come somewhere around 53. Fine. And from the more than type, you can see that more than or equal to 0, we have 53 students. So more than or equal to 0, we have 53 students, and more than or equal to 90, we have 8 students. Okay, that is this point, that will be somewhere here 8. Now in the question it is asked the point of intersection of the less than type and the more than type cumulative frequency curve. So what does this mean? We have to find a line which will pass through all these points. Okay, and again for the less than type, we have to find a line that will pass through this point, and finding this line or a curve that will pass through this point is a different task. I will not go into the details of how it can be done, but there are many ways to do it, and for a student of class 9 that is not required for all of you to know. In fact, this plotting of this less than type and more than type, this itself is not given in the textbook, but it is asked as a question in exemplar, so we are learning it just to have an understanding of how statistics could be depicted in different ways. Okay, and this kind of plotting is generally called as a ogive. Okay, now what I will do is that I will show a trend line or a curve that will pass through all these points. Okay, again this is not required for all of you to learn, this is beyond your syllabus. At some point in your life, if you are learning mathematics, you will learn how to do this. Okay, now I have joined all the data points using a curve. Okay, So the curve almost passed through all the data points. Okay. Now what is the point of intersection of the two curves? You can see the point of intersection of the two curves is somewhere here, right? At this particular point, the two curves will meet. And what will be the corresponding marks? Okay. Let us find the point. It will come somewhere here. And this value will come to be somewhere around 66.4, which is what you actually calculate in the textbook, right? As I said before, these are data points corresponding to table 13.13 and table 13.14. Okay. And in the textbook, this is a solved example, and you will find the medium to come to be around 66.4. And instead of numerically calculating all this point, you can actually plot, both the less than type and more than type, find the intersection point, and you can find what is the median value. Okay, this is finding the value from a visual point of view. Again, you don't have to learn about finding this trend line, that is beyond the syllabus. Therefore, the answer to the given question will be, this is something nothing but median. Consider the following frequency distribution. We have a table given and we have to calculate the upper limit of the median class. So the classes are not represented in a continuous fashion. You can see it is coming from 0 to 5, then the next class is 6 to 11, and then 12 to 17. So it is not in a continuous fashion, but it is in a discrete form. So I will rewrite this table once more. Okay, so we have the data given in a tabular form. So the first thing that you can do is that we will find the cumulative frequency. Okay, and that will be, the first value is simply 13. The next is 13 plus 10, it will be 23. Okay, then it will be 23 plus 15, you will get 38. Similarly, 38 plus 8, you will get 46, and then 57. We can also write summation of all the frequency to be 57. Therefore, we have n equal to summation fi is equal to 57. That means the middle value, that is n by 2, will come to be 28.5. Where will this 28.5 lie in this data set? It will be between 23 and 38. Okay, that means it is in this particular class, that is 12 to 17. So the median class is 12 to 17. So the answer will be 17. Is it so? No, the answer is not 17. Why? Because we have not re-represented this class intervals into a continuous form. So when we do that, how it will come? So each of this class is not in the continuous form, right? It is 0 to 5, then it goes from 6 to 11. So how can we re-represent these class intervals into the continuous form? Let us do that here. So when I add and subtract 0.5, I can rewrite all the class intervals in this form, and now it is in a continuous fashion. It is 0 to 5.5, then 5.5 to 11.5, 11.5 to 17.5, and so on. So in this question, we found out that the median class to be 12 to 17. Okay, and in the continuous form, we can see that the class interval will be 11.5 to 17.5. And what is the upper limit of the median class? It will be 17.5. So the answer is 17.5. Therefore, the upper limit of the median class is 17.5. Some of you may have doubt that why I didn't reduce 0.5 from 0. Of course, you can do that. You can write it as minus 0.5. But for the neatness, I didn't do that. We are only looking at positive data points. So I started from 0. Okay. I will go through this problem once more. In the given problem, the class intervals has numbers that are included within the class, right? So 5 is included within this class. 6 and 11 are included within this class. Similarly for all the classes. Okay. What we have to do, we have to make this into a smooth or continuous class interval, and for that what we did, we add and subtract 0.5 from both the extreme limits of the class. Okay, Let's say for 6 to 11 class, I add and subtract 0.5 from both the ends. 6 becomes 5.5 and 11 becomes 11.5. Similarly for all the classes. Finally, we can ask one more question. What will be the lower limit of the median class? Lower limit of the median class will be 11.5. For the following distribution, the model classes, so this is in the form of less than type frequency. So what I will do is that I will convert this into the regular frequency distribution. The first thing, the class intervals for marks I can write as 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60, and correspondingly I can write the students as, for 0 to 10 it will be simply 3 students. For 10 to 20, how do we calculate? For 10 to 20 I can calculate using below 20 and below 10, or 12 minus 3, 9. 9 will be the number of students between 10 to 20. Next, for 20 to 30, how many students will be there? It will be 27 minus 12, we will get 15. Then similarly for the next class, I can write 57 minus 27 or 30 students. Similarly, if you do, you will get 18 and 5. Now, what is the model class? Model class is the class which has the highest frequency, and that will be 30 to 40. Okay, 30 is the highest frequency and that is corresponding to 30 to 40, or option C. The time in seconds taken by 150 athletes to run a 110-meter hurdle race are tabulated below. So we have the table given and it shows class intervals representing different times taken to complete this hurdle race. The number of athletes who completed the race in less than 14.6 seconds is. This is what we have to find. What we have to do is that we have to convert this frequency distribution into a less than type. Let's do that. So first I will write all the less than type and the corresponding cumulative frequency. So we can start from up to 14. Now what will be the corresponding cumulative frequency? Up to 14 it will be simply 2. Okay. Up to 14.2 it will be 2 plus 4 and that will be 6. Up to 14.4, okay, we have to add 2 plus 4 plus 5, that will come to be 11. Similarly, I will get 82, 130. How do I calculate up to 15? I have to calculate all the data points. So that will be 2 plus 4 plus 5 plus 71 plus 48 plus 20. Okay, you will get 150. In the question we are asked the number of athletes who completed the race in less than 14.6 seconds and that will be 82 athletes. Fine. Let us ask one more question. What will be the number of athletes who took more than 14.6 athletes to complete the race? Let us ask one more question. What will be the number of athletes who took more than 14.6 to complete the race? We can easily calculate this, right? What we have to do? We have to do 150 minus 82. You will get the answer for this particular question. So that is 150 minus 82 will come 68. That means 68 athletes took more than 14.6 to complete the race. Another way to do is that to find the number of athletes who took more than 14.6 seconds, we have to simply add these two data points, that is 48 plus 20. You will also get the same 68. An event is very unlikely to happen. Its probability is close to. So it is said that the event is very unlikely to happen. Okay. Let the event be denoted as A. If the event cannot occur, then its probability will be P of A bar equal to 0. What we have to do in this problem is that we have to check which option is closest to 0, and that will be option A, 0.0001. Option A, 0.001 is the closest to 0 and it is the answer. Next question. The probability expressed as a percentage of a particular occurrence can never be. The four options are less than 100, less than 0, greater than 1 and anything but a whole. We know that probability of an event can range from 0 to 1. Now, if we express this in terms of percentage, it can range from 0% to 100%. Now we will go through the options. Option A is less than 100 and that is possible, right? Option B is less than 0 and that is not possible. Option C is greater than 1, that is possible. And option D is anything but a whole. It is also a possible value. Option B less than 0 is the answer. Why? Because this is impossible. Why? Because probability can never be negative. The probability that a non-leap year selected at random will contain 53 Sunday is. That is, if we select a non-leap year at random, okay, what is the probability that it will have 53 Sundays in it? In a non-leap year, we will have 365 days. So the number of weeks in a non-leap year we can calculate as 365 divided by 17. And you calculate, you will get something around 52.14, or we can write the same answer as 52 weeks plus 1 day. So in 365 days we will have 52 complete weeks, okay, plus 1 day. So in 52 weeks, we definitely have 52 Sundays. Fine. In 52 weeks, we will definitely have 52 Sundays. Now the question is about this 1 day. What could be this day? It can be any of the 7 days in a week. So we have 1 day out of 365 days, for which we do not know whether it will be a Sunday, Monday, Tuesday or whatever. Okay. So probability of this 1 day to be a Sunday will be, how many possibilities are there for this 1 day? We have 7 possibilities, right? It could be Sunday, Monday, Tuesday all the way up till Saturday. So there are 7 possibilities and what we need is Sunday. So this probability will be nothing but 1 by 7. Why? We have 7 possibilities, that is all the 7 days of the week, and what we need is we need a Sunday, and we have only one Sunday per week, so the overall probability will be 1 by 7. So the answer is option A. Let us ask one more problem from the same question. That is, what if a leap year is selected at random instead of a non-leap year? We are selecting a leap year at random. What will be the probability that it will contain 53 Sundays? How do we do it? Out of 366 days, we can see that 366 divided by 7, if you do, what we get is 52 weeks plus 2 days. Again, in this 52 weeks, we have 52 Sundays, and that is something we are sure about. The question here will be what will happen in these 2 days. We have to see the probability of a 7 occurring in this 2 days. Okay, what are the probable events for this 2 days? It could be, okay, it can be a Sunday, Monday, okay, it can be a Monday, Tuesday, and so on. It can be a Saturday, Sunday. So how many possibilities are there? We will have 7 possibilities. Okay, we will have 7 possibilities for this 2 days. And out of these 7 possibilities, how many possibilities will have a Sunday? It will be only within Sunday, Monday and Saturday, Sunday. So in Sunday, Monday and Saturday, Sunday, we will have Sunday, right? So the probability will be 2 by 7. Once more, why 7? Because we have 7 possibilities, right? 7 possibilities for this 2 days. And why 2 here? Out of the 7 possibilities, 2 have Sundays in it, right? This is this 2. The probability of getting a bad egg in a lot of 400 is 0.035. The number of bad eggs in the lot is. So we can write the total number of eggs is given as 400. It is also given that probability of a bad egg will be, we can write as number of bad eggs divided by total number of eggs, or the probability of a bad egg is given as 0.035 is equal to number of bad eggs divided by number of total eggs is 400. Therefore, number of bad eggs we can write as 400 into 0.035 or 14. So the answer will be option B, 14. A girl calculates that the probability of her winning the first prize in a lottery is 0.08. If 6,000 tickets are sold, how many tickets has she bought? 4 options are given. How do we solve this? I will go step by step, okay? If I randomly buy 1 ticket, what will be the probability? Let's say if the girl buys 1 ticket, okay, randomly, then the probability of winning will be P is equal to 1 by 6,000, right? That is, there are 6,000 possibilities. We have 6,000 tickets or 6,000 possibilities, and out of which only one will be a winning ticket, right? Now if she is going to randomly select 1 ticket from 6,000, her probability will be 1 by 6,000. If you have some doubt, continue to listen, okay? Let's say the girl buys all the 6,000 tickets, okay? So she has bought all the tickets. Then her probability of winning will be P is equal to 6,000 by 6,000. Why? There are 6,000 tickets available and she has bought all the 6,000 tickets, right? So definitely she is going to win the lottery. So 100% definitely she is going to win the lottery. Now it is given that her probability of winning is 0.08. Okay, that means 0.08 is equal to number of tickets she bought divided by total number of tickets or 6,000. So we will get the number of tickets the girl bought is equal to 6,000 into 0.08 or 480. So the answer is 480 or option C. A school has 5 houses A, B, C, D and E. A class has 23 students. Okay, 4 are from house A, 8 from house B, 5 from house C, 2 from house D and the rest from house E. A single student is selected at random to be the class monitor. The probability that the selected student is not from A, B and C is, in this problem what we have to do is that we have to find the probability that the selected student is not from A, B and C. That means the student can be from house D or house E. Once more, the probability that the selected student is not from A, B and C, or we can say that the selected student can be from house D or house E. Okay, so what will be the probability? That is, probability of a student can be from house D or house E will be total number of students in house D plus house E divided by the total number of students across all the houses. So the probability will be the number of students in class D and class E divided by the total number of students, and that will be in class D we have 2 students plus in class E we will have 4 students. It is a basic arithmetic, you can calculate from the question. And in the entire school we have 23 students, nothing but 6 by 23. So the answer is option B, 6 by 23. In a family having 3 children, there may be no girls, 1 girl, 2 girls or 3 girls. So the probability of each is 1 by 4. Is this correct? That's the first question. Justify your answer. Okay. So what will be the probability of each of these case? We will explore one by one. Let us look what are the possibilities for the first, second and third child. Okay. So the first child can be a boy or a girl. Again, the second child can be a boy or a girl. Similarly, the third child can be a boy or a girl, right? So altogether, what will be the number of possibilities? It will be 2 into 2 into 2 equal to 8 possibilities are there overall for this family. And let's say we talk about probability of no girls. That means the first, second and third all are going to be boys. Once more, the probability of no girls will be a combination of first child is a boy, second child is a boy and third child is also a boy. This is one combination. And what are the number of possibilities? There are 8 possibilities. So there is only one combination for 3 boys given by total 8 possibilities. Together the answer is 1 by 8. Second question, probability of one girl. Second is probability of one girl, and that will be, we can have a case like first one is a girl and second is a boy, third is a boy. Second is first is a boy, then a girl and then a boy, and third possibility is first 2 are going to be boys and then a girl. So in all the 3 we have one single girl. What are the total possibilities? There are 8 possibilities. So this will be 3 by 8. Next, probability of 2 girls. We can write as, can be first 2 as girls and then a boy, or then it could be a girl, then boy, then girl, or it could be a first child is boy and then 2 girls. And together we have 8 possibilities and the final probability will be 3 by 8. And last, the probability of 3 girls. There is only one combination possible for this, that is girl, girl, girl divided by the total number of possibilities are 8. So together we have 1 by 8. So we have found out the individual probabilities of no girls, that is 1 by 8. 1 girl means 3 by 8. 2 girls means 3 by 8 and 3 girls means 1 by 8. Okay. Now if you look at these possibilities, okay, these are the 8 possibilities for this family. We are writing everywhere 8, right? This 8 has come from this 8 possibilities. Okay. It's similar to the tossing of a coin. We have, let's say we are tossing 2 coins. We used to write head head, head tail, tail head and tail tail. In this problem we have boys and girls and there are 3 children. So it is like tossing a coin 3 times. This problem is very similar to tossing a coin 3 times. When you toss a coin 3 times, there also we will have 8 possibilities. Okay. Coming back to the problem, the answer will be the probability of each equal to 1 by 4 is not correct. Coming back to the problem, the probability of each equal to 1 by 4 is going to be Not correct. It is not correct. Why? We have just found out the individual probabilities of all the 4 cases, right? Now why this is not 1 by 4 for all the cases? The answer is each of these events, okay, each of these events are not equally likely, right? Once more, why each of the probability is not 1 by 4? The reason is that each of these events, right, 1 girl, 2 girl, 3 girl, no girls, these are not equally likely. If it is equally likely, then it will be 1 by 4. Here it is not equally likely, and therefore it is not 1 by 4, it is different values. It is a general tendency that many students will wrongly assume that there are 4 possibilities, 0, 1, 2, 3, right? 0, 1, 2, 3 girls, and therefore they will think that okay, there are 4 possibilities, 0, 1, 2, 3, and each of this will have a probability of 1 by 4, but that is not correct as we have calculated in this problem. Right? This is going to be 1 by 8. This will be 1 by 8. A game consists of spinning an arrow which comes to rest pointing at one of the 3 regions 1, 2 or 3. Are the outcomes 1, 2 and 3 equally likely to occur? Give reasons. So in this problem we have a game in which we are going to spin this arrow, okay, and once you spin the arrow can reach in any position. It could be like as shown in the image 1, or it could land in somewhere this position, or it could land somewhere in this position. Now the question is, are the outcomes 1, 2 and 3 equally likely? Visually you can understand that it will not be equally likely. Why? Because area for 1 and area for 2 is much smaller than area for 3. Let us calculate the individual probabilities for 1, 2 and 3. I will write as probability for the arrow falling into the region 1 will be, I can write as area of region 1 divided by the total circle area. And we can write as area of region 1 will be 1 by 4 into pi r square divided by pi r square, or nothing but 1 by 4. Similarly, the probability for region 2 will also be equal to 1 by 4, and probability for region 3 will be 1 by 2. Okay, how 1 by 2 will come? This will be 1 by 2 into pi r square divided by pi r square. Okay, and that's how we get probability of region 3 is nothing but 1 by 2. Now you can see that probability of 1 is 1 by 4, probability of 2 is 1 by 4, and probability of 3 is 1 by 2. That means it is not an equally likely outcome. If it was equally likely, it should be 1 by 3, 1 by 3, 1 by 3, but that's not the case here. The next question is, Romeo throws 2 dice once and computes the product of the numbers appearing on the dice. Juliet throws 1 die and squares the number that appears on it. Who has the better chance of getting the number 36? Why it is so? So let us look at the probability for both Romeo and Juliet. What will be the probability for Romeo? Romeo is going to throw 2 dice. So let us first check what are the total number of possibilities for Romeo. When you throw 2 dice, the number of possible outcomes will be 36, right? Each die has 6 possibilities, numbers 1 to 6, and when you throw 2 dice, you will have a total of 36 possible outcomes. So that is the total number of possibilities, 36. And what is the required event here? We need to get number 36, and that is possible only when we have 6 and 6 as the outcome, and 6 and 6 will only occur once, so that is 1 by 36. Now we will look at the probability for Juliet. Now Juliet is only going to throw a die once. So what are the possibilities she has? Only 6 possibilities, 6. And she is going to square the number that is appearing on the dice. Okay, so we have only 6 possibilities, and that is 1 to 6, and if we are going to square the number that is appearing on the dice, To get 36, there is only one possibility, that is she has to get 6, or that means there is only one possibility. Now we can see that probability for Juliet 1 by 6 is a value much higher than 1 by 36. Once more, 1 by 6 is much greater than 1 by 36. That means Juliet has a much higher probability of getting the number 36. Find the value of P if the mean of the following distribution is 20. So we have been given a data set, and for each data point we have the corresponding frequency. How do we solve this? So in this problem we have to calculate the mean, because that is a value that is given to us, mean equal to 20. So we use that information to proceed with the problem. So equation for mean is x bar equal to summation fi xi divided by summation fi. Let us write it. The first value will be 15 into 2, okay, plus 17 into 3 plus 19 into 4 plus 20 plus p into 5p plus 23 into 6 whole divided by 2 plus 3 plus 4 plus 5p plus 6. So let us rearrange. You will get 5p square plus 100p plus 295 divided by 5p plus 15, and this value is equal to 20. 20 is given in the question. So we will make the fraction into smaller form. In this entire term we can reduce by the factor 5. So we will get p square plus 20p plus 59 divided by p plus 3 is equal to 20. Further I will rearrange. I will get 20p plus 60 is equal to p square plus 20p plus 59. We can see that this 20p and this 20p will get reduced. 60 minus 59 you will get, and so we will obtain p square equal to 1 implies p equal to 1. The answer to the given problem is p equal to 1. The daily income of a sample of 50 employees are tabulated as follows. So we have a table of several classes of income and corresponding number of employees. Find the mean daily income of employees. Now you can see that the intervals are in discrete form. It is not in a continuous form. For example, the first class is 1 to 200, and then it is 201 to 400, and then it is 401 to 600, and so on. How do we solve this? Let us first convert this into the tabular form, and then we will proceed. Okay. Here some of you may have a doubt that do we have to convert this 1 to 200, 201 to 400, all these into the continuous fashion? Actually you can do that, there is no harm in doing that, but in this problem it is not required. For example, you take the first class interval 1 to 200, okay. If you are going to convert this into the continuous fashion, how would this will come? It will be 0.5 to 200.5. I will write it. So now I have converted all the class intervals into the continuous fashion. Okay. Now let us calculate the midpoint for all these class intervals. This will come to be 100.5, 300.5, 500.5 and 700.5. Now see, what is 200 plus 1 by 2? You will get 100.5. And what is 0.5 plus 200.5 by 2? You will get the same 100.5. You take any other class, let's say 401 plus 600 by 2, you will get 500.5. And if you do 400.5 plus 600.5 divide by 2, you again get the same 500.5. That means there is no need to convert this discrete form into the continuous form to get the xi. Okay, so now what I will do is that I will remove this continuous interval to make up some space to solve the problem. There is no harm in all of you converting into this form and doing it, but what I meant is that it is not required. You can save some time by not doing this. Now let us calculate the DI values. I will choose 500.5 to be the common subtraction. So DI is equal to xi minus 500.5. Okay, I will get minus 400 minus 200, 0 and 200. So let me write the ui value. I will write di by, I will use 100 as the denominator. I will get minus 4, minus 2, 0 and 2. Now I will compute fi ui. I will get minus 56, minus 30, 0, 14. Let me find the summation values. I will get summation fi is equal to 50 and summation fi ui I will get minus 72. So altogether I can compute the mean value as x bar is equal to a plus h into summation fi ui divided by n. So here a is 500.5 plus h I have taken as 100. Summation fi ui is going to be minus 72 divided by n is 50. That means x bar is equal to 356.5. 365.5 is the mean daily income of the employees. The mean of the following distribution is 62.8 and the sum of all the frequencies is 50. Compute the missing frequency f1 and f2. So we have a table given with the income and the number of employees, and for two particular class intervals the number of employees are given as f1 and f2, that is in a frequency which is missing, and we have to find it. So first I will convert this into the tabular form. Let's do that. First I will write the midpoints of all these class intervals. Okay, I will get xi as 10, 30, 50, 70, 90 and 110. Now I will calculate di value. Di is equal to xi minus, I will take the value of a as 70. So I will get minus 60, minus 40, minus 20, 0, 20 and 40. Now I can write ui value as di by h, and h I will take as 10. So I will get minus 6, minus 4, minus 2, 0, 2 and 4. Now I will compute fi ui values. So fi ui values are going to be minus 30, minus 4 f1, minus 20, 0, 14, 32. Now I will do the summation for fi and fi ui. Summation fi will come to be 30 plus f1 plus f2. Okay, and summation fi ui will come to be minus 4 minus 4 f1. And one more thing, summation fi is equal to 62.8. So now we have two equations. Okay, equation number 1 and one more equation, and using these two equations and the information provided in the question, we have to find the value of f1 and f2. So in the question it is given that mean is equal to 62.8. So let us use the equation of mean. So x bar equal to 62.8. That means 62.8 is equal to, I can write it will be equal to a plus h into summation fi ui by n, right? And here I will substitute 62.8 is equal to a is, in this problem I have taken it as 70 and h I have taken it as 10 into summation fi ui is going to be minus 4 minus 4f1 divided by, and summation n is going to be 50. There is a mistake, this is going to be 50. Okay, note I wrote earlier this equation wrong, it was supposed to be 50, I wrote 62.8. okay, so correct it. So now let us come back to this equation and let us try to rearrange it. Okay, this entire equation has only one unknown value, that is f1 value, and we can compute it easily, and when you do it you will get f1 to be, you will get f1 to be 8. And once you get f1 to be 8, you can substitute this into this equation. Okay, you will get f2 to be 12. Once more, we have the information for x bar. Okay, so we use the equation for x bar, we substitute all the available information, so we get an equation which only one unknown as f1. You solve this, you will get f1, and once you get f1 you can use that information to substitute in this equation and you will get f2. So the two unknowns are found out. Now in this problem you can make your life a bit more difficulty by doing one mistake. It's not a mistake but one approach. Okay, in this particular stage of solving the problem, let's say instead of 70 I took 50. Okay, if I take di is equal to xi minus 50, then what would happen is that here it will not come to 0. This will be some term in terms of f2, and this fi ui will have a value in terms of f1 plus some f2 value. And then once this equation has some f2 value, what would happen is that when you try to substitute in the mean equation, this equation also will have f1 and f2. Then you will have two equations using f1 and f2 and you will have to solve it. Okay, you will still get the correct answer, but it would be a bit more time consuming. So the smart way to do is that you choose this value that we have to subtract from the midpoint in such a way that it will remove at least one of the unknown values. That is what I have done here. I have two unknowns f1 and f2 and I chose 70 corresponding to one of the frequency, that is I done here, and then my life was easy. The mileage in kilometer per liter of 50 cars of the same model was tested by a manufacturer and details are tabulated as given below. We have a table giving mileage in different classes and the corresponding number of cars for particular classes. Find the mean mileage. The manufacturer claimed that the mileage of the model was 16 km per liter. Do you agree with the claim? It's a straightforward problem. What we have to do is that we have to find the mileage and see whether it is more than 16 km per liter or not. Let's do that. So let us first write the midpoints of all these classes. So I can write for 10 to 12, I can write the midpoint as 11, then 13, then 15, and then 17. Now I will directly write the ui value. So I'll take ui is equal to x minus 15 by 2. I take 15 as my common subtraction and I divide by the class interval. I get minus 2, minus 1, 0, 1, and last fi ui value, fi ui, I'll get minus 14, minus 12, 0, 13. Now I can write the summation values. Sigma f is nothing but 50 and sigma fi ui you will get minus 13. Now we directly apply this information into the mean equation. Mean x bar is equal to, I am going to directly substitute, it will be 15 plus 2 into minus 13 divided by 50, and once you do you will get x bar is equal to 14.48, and here we are calculating the mileage, so I can write kilometer per liter. So the mean mileage of all the car is 14.48 kilometer per liter, and that is below the claim provided by the manufacturer, right? So we cannot agree to the claim. The following table shows the cumulative frequency distribution of marks of 800 students in an examination. Construct a frequency distribution table for the data above. So we have a less than type frequency distribution, and this is a simple problem. All you have to do is to convert this into a frequency distribution table, and mostly you will be doing a lot of subtractions. Let's do that. Now I will write the class intervals for each of the marks. So we have class. Let me write like this. I will do 0 to 10, then 10 to 20, then 20 to 30, and similarly. Now the main question, how to write the frequency. So the first one is going to be simply 10, right? How about the second frequency? What we have to do is 50 minus 10, you will get the next value. That is 50 minus 10 equal to 40. The next one will be 130 minus 50. 130 minus 50, you will get 80. And similarly you can fill the rest of it. I will quickly do now. Now how to check that whatever you have written is correct or not? Simple way is to add all these elements, and it should come to 800. Once more, if sigma fi comes to 800, same as this value, that means you have done the correct thing. Form the frequency distribution table from the following data, and this time we have a more than type frequency distribution, and we have to convert it to the regular frequency distribution. Let's do that. Now I will write the corresponding classes. I can write as 80 to 90, 70 to 80, 60 to 70, and similarly. And for the frequency, what would be the first frequency? It will be simply 4. What about the second one? It would be 6 minus 4, you will get 2. The next one will be 11 minus 6. Now I'll write the rest of it. So it's done. Now how do we check this? We can add all these values, and when you total it, it should come as same as 34. Summation fi is equal to 34. And if you get summation fi equal to 34 by adding all this value, which is same as this, that means you are correct. Find the unknown entries A, B, C, D, E, F in the following distribution of heights of students in a class. So we have been given a table, a frequency distribution table along with the cumulative frequency, and there are some points not available to us that we have to find out. Let's do that. So we have been given a table of heights in different classes, the corresponding frequency and the cumulative frequency. okay, and then we have a lot of unknown values here that we have to find out, okay, and it's also given that the total frequency is 50. From the very first class interval, the frequency is given, and it also means that the cumulative frequency will be same as the frequency because it's the first class. So we can say that A is equal to 12. Let's move further. We need to find B. For the second class interval, we can imagine a scenario of height below 160, and for height below 160 we have the cumulative frequency as 25. This 25 means it is a sum of B and 12. So I can write 25 is equal to B plus 12, and it means that B is equal to 30. Now we know A and we know B, okay, we have to find C. What will be the value of C? C will be a sum of these three values, that is 12 plus B plus 10 will be equaling C. So I can write C is equal to 12 plus B plus 10, and we get C as 35. Next we have to find D. What will be the value of D? We have the cumulative frequency as 43, and 43 will be a sum of all these values, that is 12 plus B plus 10 plus D will equal 43. So I can write 43 is equal to 12 plus B plus 10 plus D. I have the value of B as 13. I'll resubstitute back and I will get D. Once you do, you will get D as 8. To find D, there is one more way to look at it, that is 43 will be equaling C plus D. Once more, 43 will be as same as C plus D. Once you add C and D, you will get 43, and we have just calculated C value here, and this may be a quick way for some of you. So you can prefer either continuous addition and equating to a cumulative frequency, or you can use this methodology, right? I will do this to find E. See, to find E, what I can do, it will be 43 plus E, you will get 48. 48 is equal to 43 plus E, implies E is equal to 5. I can find this way, that is this way, or the first method, that is I add all these points. Okay, I add 12 plus B plus 10 plus D plus E, I will get 48. This way also you will get the same E value. So whatever method you prefer, you do that. And the last value is F. F I can find as 48 plus 2 will equal F, or 12 plus B plus 10 plus D plus E plus 2 will equal F. Both ways are fine. I will go for the simple way, that is 48 plus 2 is equal to F, that means F is equal to 50. So I have all the values: A equal to 12, B equal to 13, C equal to 35, D equal to 8, E equal to 5 and F equal to 10. Weekly income of 600 families is tabulated below. So we have a table consisting of weekly income provided in different class intervals, and correspondingly we have the number of families, that is the frequency. I have to compute the median income, that is the income that will come at the exact middle of this data set. Let's do that. So I have the table ready. Okay, in the question we have been given this information, that is summation Fi is equal to 600. That means n equal to 600. That means we have information of 600 families. So what will be the middle point? It will be n by 2 is equal to 300. Okay. In this particular question, we have to find the income of the 300th family. Okay, that will be the exact middle value or the median income. So keep this in mind, that is the middle value is 300. Okay, now what I will do is that I will find the cumulative frequency and I will denote as CF. Okay, so the first value will be as same as frequency, that is 250. The second value will be 250 plus 190. I will get the cumulative frequency and that will be 440. Okay, now see that by the second class interval, that is for weekly income 1000 to 2000, the cumulative frequency reaches 440, and we have seen that the middle value is 300. That means the middle value will be in this particular class, that is 1000 to 2000. So I need not do all the other calculations, that is not required. We can directly jump into the equation of median, and that is median is equal to L plus n by 2 minus CF divided by F whole into H. Okay, so let's substitute. What is L? L is the lower limit of the median class. So we have the median classes. So the lower value of median class is 1000. 1000 plus n by 2 is nothing but 300, and the cumulative frequency, this cumulative frequency is the cumulative frequency of the preceding class, that is 250. So minus 250 divided by F. This F is what? This F is the frequency of the median class, so that is 190. 190 into H. What is H? H is the class size, that is again 1000. You do all the calculations and you will get median as 1263.15. The median income is 1263.15. The weight of coffee in 70 packets are shown in the following table. So we have a table providing weight in different class intervals and the corresponding number of packets in each classes. Determine the model weight. So from the table directly, we can see that the highest frequency is for the class 201 to 202 grams and the corresponding frequency is 26. So this is the model class. Okay, now let's find the mode weight or model weight. So we have the equation. Mode is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 whole into H. So now we will substitute the values and we get L is the lower limit of the model class, that is 201. Okay, F1 is what? F1 is the frequency of the model class, that will be 26. F0 is what? F0 is the frequency of the preceding class and F2 is the frequency of the succeeding class. Fine. And H is nothing but the size of the class intervals. So we will substitute and we get 201 plus 26 minus 12 divided by 2 into 26 minus 12 minus 20 into 1. Substitute and you will get the answer as 201.7 kg. Two dice are thrown simultaneously. What is the probability that the sum of the numbers appearing on the dice is 7, a prime number, and 1. So we will solve this one by one. The first one is 7. So when you throw a dice, we will have a total of 36 possibilities, right? Total possibilities are 36 for a 2 dice. Now the first thing is that the sum of the numbers appearing on the dice has to be 7. So what are the possibilities to get 7 as the sum of two numbers? Let us list it down. The favorable outcomes will be, we can have 1 6 as 1, and the reverse is possible, 6 1, okay. And second is 3 and 4, 3 plus 4 is 7. We can also have 4 comma 3, okay. And then we can have 2 5, or we can also have 5 2. So these are the possibilities in which the sum of the numbers on the two dice will be 7, okay. So we have 1 2 3 4 5 6 6 favorable outcomes. Therefore the probability will be 6 by 36 equal to 1 by 6. Let's move to the next problem, a prime number. So what are the possible prime numbers that we can expect when we throw two dice together? That means the sum of the numbers. The maximum sum that we can get is 12, right? That is, when we get two dice as 6 and 6, then 12 will be the largest sum that we can get when we throw two dice. So what are the list of all possible prime numbers less than 12? We have 2, 3, 5, 7, and that's it. No, we can have 11 also. So there are 5 possible prime numbers that we can get when we throw two dice and we count the sum of the numbers appearing on it, okay. Now what we do is that we will see what are the favorable outcomes. To get 2, we need to have 1 comma 1, okay, that's the only possibilities. To get 3, we can have 1 comma 2 or 2 comma 1, both are possible, okay. To get 5, what are the possibilities? We can get 1 4 or 4 1, both are possible. Then we can expect 2 3, okay, or 3 2, and then that's it for 5. For 7, we can expect, what are the possibilities? We can have 3 4, okay, or 4 3. We can also have 2 5 or 5 2, right? Any more? Yeah, we can have 1 comma 6, right? 1 comma 6 or 6 comma 1. That's it. And for 11, what are the possibilities? We can have 5 6 or we can have 6 5. Any more chance? No. So together we have 1, 2 outcomes here, 4 outcomes here, 6 outcomes here, and 2 outcomes here. So together that is 1 plus 2 plus 4 plus 6 plus 2. So the probability of getting a prime number as the sum of rolling two dice is 1 plus 2 plus 4 plus 6 plus 2 divided by the total possibilities, that is 36, and once you do, you will get 15 by 36 or 5 by 12. Last question is, we have to get the sum of rolling two dice as 1, and any chance of this? No, there is no chance. That means the probability is 0. We cannot have a situation where we will get the sum of two numbers as 1 when we roll two dice. Two dice are thrown at the same time and the product of the numbers appearing on them is noted. Find the probability that the product is less than 9. So what we have to do is that we have to find the probability of product is less than 9. Let's do that. When we roll or when we throw 2 dice, what are the possible product that we can get? When we throw 2 dice, okay, what are the 2 extreme product that we can get? It can be 1 into 1 equal to 1, that is the lowest product that I can get, and the largest product I can get is 6 into 6, right? The smallest product possible is, it's for 1 comma 1, okay, then we will get 1 as the product. The largest product possible is for 6 comma 6, and then we will get 36. Now to solve this, what I will do is that I will choose a number on the first dice, and then I will see what are the possibilities for the second dice in such a way that the product will be less than 9. Let me do this. So I'm checking the favorable outcomes, okay. We know that the total possible outcomes will be 36 for rolling 2 dice together. Now we are just going to find the favorable outcomes. So let's say I get number 1 from the first dice, okay. Now what I'm going to do is that I'm checking what are the possible numbers that I can get on the second dice such that the product will be less than 9. So with 1 appearing on the first dice, we can have any number on the second dice, right? If the second dice is having number 1, then 1 into 1 is going to be 1, it is less than 9. And let's say the other extreme, that is I get 6, okay. If I get 6, 1 into 6 is equal to 6 and it is less than 9. That means I can have any number on the second dice and all will be a favorable outcome. So I can have 1, 2, 3, 4, 5, 6, all are possible. That means I can have 6 outcomes favorable, okay. Now let's go to the second. That means I get number 2 on the first dice. Now I will see what are the possible numbers that I can get on the second dice such a way that the product will be less than 9, okay. What are the possibilities? 2 into 1 is going to be 2, it is less than 9, and 2 into 4 is going to be 8 and it is going to be less than 9, but 2 into 5 we will get 10, which is more than 9. So I can have 1, 2, 3 and 4, right? Only 4 numbers are possible on the second dice. That means 4 possible outcomes, okay. Again, why 4? 2 into 4 is 8 and that is less than 9. But if 5 was there, then 2 into 5 is going to be 10 and it is not less than 9, okay. We move further. 3. What are the possible numbers for 3? 3 into 1 is going to be 3, it is less than 9, and 3 into 3 is 9, so it is equal to 9 and not less than 9. So only 2 possibilities are available, 3 into 1 and 3 into 2. Both will get a number less than 9. So 1, 2. That means I have 2 possible outcomes. For number 4, that is I get number 4 on the first dice. Now what are the possible outcomes? I can have 4 into 1, okay. 4 into 2 is possible. 4 into 3 is not possible because 4 into 3 is 12 and that is more than 9. So only 2 outcomes, 1, 2. I can have 5 into 1, it is going to be 5 less than 9. 5 into 2 is going to be 10, it is not possible. So I can only have 1, that means only 1 possibility. Similarly for 6, I can only have 6 into 1. 6 into 2 will be 12, it is more than 9, so only 1 possibility. So together, what are the favorable outcomes? It is going to be 6 plus 4 plus 2 plus 2 plus 1 plus 1. That will come to be 16. So the required probability is 16 by 36 or 4 by 9. Two dice are numbered 1, 2, 3, 4, 5, 6 and 1, 1, 2, 2, 3, 3 respectively. They are thrown and the sum of the numbers on them is noted. Okay. Find the probability of getting each sum from 2 to 9 separately. Probability of the sum of the numbers on the two dice from 2 to 9. Okay. And in this problem there is a difference in dice 2. On dice 1 I have a regular dice, but on dice 2 I have a different set of numbers. It is going to be 2 1s, 2 2s and 2 3s. In this particular problem the total number of possibilities will be still 36. Okay, that is not going to change because we have 6 numbers here, 6 numbers here. That means the total possible outcomes will be 6 into 6, 36 possible outcomes are there. Now we have to find the favorable outcomes. Okay, again what I will do is that I will keep the dice 1 as constant and I will check what are the possible outcomes with dice 2. Okay, let's start by finding the probability of the sum of the numbers on the two dice as 2. Then we go step by step up till 9. Okay, so starting with probability of the sum of the numbers of the two dice as 2. So on the dice 1, let's say I get number 1. On dice 2, what are the possible outcomes? I can only have 1, right? Then only I will get 1 plus 1 equal to 2. But on dice 2 we have 2 ones, okay, not just a single one. I have 2 ones. That means I can have 1 or the second one, and together I can have 2 possibilities. Fine. For any other number on dice 1, let's say I get 2 on dice 1. Is there any possibility on dice 2? Nothing. No number on dice 2 will end with the sum of the number equal to 2. So probability of 2 is going to be, there are 2 favorable outcomes, okay, 2 by, and total possibilities are 36, that means 1 by 18. Now the second probability of getting the sum of the numbers as 3. Okay, let's say I am getting number 1 on the dice 1. Okay, now what are the possible numbers on dice 2 such a way that these two when I add I will get the sum as 3. I can have 2. Okay, 1 plus 2 is going to be 3, and there are 2 2s on dice 2, right? That means totally there are 2 possibilities. So on dice 2 I can have 2 comma 2. Fine. Now what happens on dice 1? I get the number as 2. What are the favorable outcomes on dice 2? On dice 2 I can have 1. 2 plus 1 is going to be 3, and I have 2 ones in dice 2. That means there are 2 outcomes possible. So I can have 1 comma 1, and together I can have 2 outcomes here and 2 outcomes here. So the probability of getting a 3 is 2 plus 2 divided by 36, or nothing but 1 by 9. I check the probability of getting the sum of the numbers from the two dice as 4. On dice 1, let's say I get number 1. What are the possible numbers on dice 2 such a way that the sum will be 4? I can have only 3, and there are 2 3s possible. So together there are 2 outcomes possible. 3 and 3 are possible, and together I can have 2 possibilities. Let's say on dice 2 I get number 2. What are the possible numbers on dice 2 in such a way that sum as number 4? There are only 2 and 2. So 2 and 2 I can get, and together I have 2 possibilities. And this time I can have number 3 on dice 1, and I can have number 1 on dice 2 and number 1 on dice 2, and together I can have two possibilities such a way that the sum will be 4. So 1 comma 1 and together two possibilities. Altogether probability of getting a 4 is, I have 2 plus 2 plus 2 divided by 36. Again, what are these? These are nothing but the favorable outcomes. So I'll get 6 by 36 or 1 by 6. What is the probability for number 5? I can have number 1 on dice 1 and the possible numbers on dice 2 are nothing. Okay. No number on dice 2 will give me a sum equal to 5. Nothing here. Okay. Now let's say I get number 2 on dice 1. What are the possible numbers on dice 2? I can have 3. Okay. Again I can have 3. So there are two outcomes possible. 3 and I can have 3. Okay. And together two outcomes possible. What if I get number 3 on dice 1? What are the possible outcomes? I can have 2 and I can have 2, and this will always come to be a sum of 5, and that means I have two possibilities. 2, I can have 2 and together two possibilities. Again I can have number 4 on dice 1 and I can get number 1 and number 1. 4 plus 1 is 5, that means I have two possibilities. Two possibilities. If I get number 5 on dice 1, is there a chance? If it is, the minimum number is 1 and 5 plus 1 will be 6, and this is not possible. So probability of number 4 is nothing but 2 plus 2 plus 2 divided by 36, and you will get 6 by 36 or 1 by 6. Similarly, you can continue to do for probability of 6 to 9. You will get probability of 6 as 1 by 6, probability of 7 as 1 by 6, probability of 8 as 1 by 9, and probability of 9 as 1 by 18. A coin is tossed 2 times. Find the probability of getting at most one head. The thing with probability questions is that it can be confusing to some of you, or you are not able to clearly understand the problem, right? Especially with the English wordings like at most, at least. It is important that we all understand the question very clearly, because then only we can solve the problem. If you are not able to understand the problem itself, then solving it is not going to happen. So in probability question, the phrases like getting at most one head or getting at least one head, these things may be confusing for some of you, but with regular practice you will be able to understand what is asked in the question. Okay, so we have to practice and learn, and in this particular problem we are being asked find the probability of getting at most one head, and what it means is that we have to get not more than one head. Okay, what I would do is that I will first write all the possible outcomes in this particular problem, that is tossing a coin 2 times. So total possibilities are going to be head and head. I can get tail and head, or head and tail, or I can get tail and tail. Now let me write the number of heads in each of the outcomes. Okay, so in this particular case I have 2 heads, that means I will get 2 heads. Okay, in this I have only 1 head, again 1 head here and 0 head here. Now in this problem we are asked probability of getting at most one head. What it means is that we have to find the probability of not more than one head. Okay, so I can have 0 head, 1 head, but nothing more than 1. So what are the possible outcomes? Only these 3 are the possible outcomes where I will get at most one head or not more than one head. So the probability will be nothing but, when you toss 2 coins, we know there are 4 possibilities, right? So we have 4, and out of which we have only 3 favorable outcomes. So that is 3. So the answer is P equal to 3 by 4. Prove the following identities where the angles involved are acute angles for which expressions are defined. Tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta is equal to 1 plus sec theta cosec theta. So this CS theta is nothing but cosec theta or cosecant theta. Let's do this. The first thing I will do is that I will convert both the LHS and RHS in terms of sin theta and cos theta. So I'll start with the RHS. So 1 plus sec theta cosec theta I can write as 1 plus 1 by cos theta into 1 by sin theta. So this is nothing but sin theta cos theta plus 1 divided by sin theta cos theta. So this is my RHS. Now I'll work on the LHS. Again I'll directly convert in terms of sin theta and cos theta. So that will be sin theta by cos theta divided by 1 minus cos theta by sin theta plus cos theta by sin theta divided by 1 minus sin theta by cos theta. Now this I can rewrite as, what I will do is that I'll make a common denominator for both sides and then I will flip the fractions at the bottom to the top. So I'll get sin theta by cos theta into sin theta divided by sin theta minus cos theta plus cos theta by sin theta into cos theta divided by cos theta minus sin theta. Again what I have done, this sin theta by cos theta is this, again this cos theta by sin theta is this 1 minus cos theta by sin theta is this term and 1 minus sin theta by cos theta is this term. Now what I will do is that we have sin theta minus cos theta here and cos theta minus sin theta here. I will take these two terms outside. So we will get 1 minus sin theta minus cos theta into sin square theta divided by cos theta minus cos square theta divided by sin theta. Again what I have done, once more I have taken this sin theta minus cos theta term outside, and since this term is not exactly like this, I had to flip this sign to negative. Now what I will do again, I will cross multiply and make the common denominator. So I will get sin theta minus cos theta multiplied by sin cube theta minus cos cube theta divided by sin theta cos theta. Now let us look at this particular part. This is similar to a cube minus b cube, and a cube minus b cube is equal to a minus b into a square plus ab plus b square. And now we have a as sin theta and b as cos theta. We will use this particular form and resubstitute here, and we will get 1 by sin theta minus cos theta multiplied by sin theta minus cos theta into sin square theta plus sin theta cos theta plus cos square theta whole divided by sin theta cos theta. Now we can see these two terms cancel out. Sin square theta plus cos square theta, we will get 1, and so we can write 1 plus sin theta cos theta divided by sin theta cos theta, which is the LHS, and this is nothing but the RHS. You can see LHS is same as RHS. Prove the following identity where the angles involved are acute angles for which the expressions are defined. So we have cos A minus sin A plus 1 divided by cos A plus sin A minus 1 equal to cosecant of A plus cot A. Let's do this. When I was solving this problem, I felt okay, this is a bit tricky and it is not as straightforward as I thought initially it was. So that's why I thought, okay, let me include this problem in this series of problems. So the way I would do is that I will take both LHS and RHS and I will individually convert it into a new form. Let me do that, starting with the RHS. So we have RHS as, so in RHS we have the relation that cot square A plus 1 is equal to cosec square A, or nothing but cosec square A minus cot square A is equal to 1. Now what I will do is that I will use the A square minus B square is equal to A plus B into A minus B form. So I can write cosecant of A plus cot of A is equal to 1 divided by cosecant of A minus cotangent of A. So we have this RHS as same here, it is converted to a new form. Now what I will do is that I will take this particular part and convert into, or convert in terms of sin theta and cos theta. Let me do that. So this will be equal to 1 divided by cosecant of theta, I can write as 1 by sin theta or sin A minus cos A by sin A. So this is nothing but sin A divided by 1 minus cos A. Now the RHS is of the form in terms of sin A and cos A. Now what I would do is that I will rephrase this original question into a new form. That is, we have the RHS here, that is this, in new terms. So what if I divide the LHS and RHS by this particular term? Then what would happen? The RHS will become 1 and we will have a new term in LHS, that is what I did is that I took this cosecant of A plus cot A into this side. This is what you get here. Now what I would do is that I have cosecant of A plus cot A in terms of sin theta and cos theta, or sin A and cos A. I will use it here. So I will get cos A minus sin A plus 1 divided by cos A plus sin A minus 1 into 1 minus cos A divided by sin A. Again, this is my new question. Okay, now I have to prove LHS equal to RHS, right? So RHS is now simply 1. If I can convert this LHS into 1, that means I have solved the problem. So this is my new LHS and I'm going to solve it. So this is equal to, I will do total multiplication of both numerator and denominator. I will get cos A minus sin A plus 1 minus cos square A plus cos A sin A minus cos A whole divided by sin A cos A plus sin square A minus sin A. Now I can cancel this cos A and cos A, and so I can write 1 minus cos square A minus sin A plus cos A sin A divided by the same as before. Now this 1 minus cos square A is nothing but sin square A. So I can write sin square A minus sin A plus cos A sin A and the same denominator as before. Now you can see the denominator and the numerator is same, or we can cancel out each other and we will get LHS to be 1, or now LHS is same as this RHS, or we have proved it. If cos A is equal to 4 by 5, then the value of tan A is equal to, we have 4 options. It's a very simple problem, we can quickly do it. Given cos A to be 4 by 5, that means if I construct a right angle triangle, right angled at B, and let this be 4 and this be 5, then we have cos A to be 4 divided by 5, which is this. Now what will be the value of BC? We can use the Pythagoras theorem, or by practice you will know this is going to be 3, and therefore tan A will be 3 by 4. The value of the expression below is cosecant of 75 degree plus theta minus secant of 15 minus theta degree minus tan 50 degree plus theta plus cotangent of 35 degree minus theta. Let's do this. So in this particular problem, we do not know the value of theta. There is no way we are going to substitute the value of theta and find the value of the expression. So that is not the way we have to approach this problem. What we have to do is that we will have to reduce this expression to a simpler form and see whether we can find the value of it. Again, any approach to find the value of this expression is not possible by substituting the value of theta, because we do not know about the value of theta. So we will have to reduce this expression to a simpler form and see. Let's do that. What I would do is that I will convert this cotangent and secant into sin theta and cot theta form, and let's see. 1 by sin 75 plus theta minus 1 by cos 15 minus theta minus tan. Now I will rewrite this 55 plus theta as this. Observe, tan 90 plus theta minus 35 plus cot 35 minus theta. Again, now I will rewrite this 75 plus theta as below. 1 by sin 90 plus theta minus 15 minus 1 divided by cos 15 minus 15 minus theta. Now I can keep this theta minus 35 in brackets, just isolating. I'm just isolating this theta minus 35 here and theta minus 15 here, so that we convert into the form tan 90 plus theta or sin 90 plus theta. Now what is tan 90 plus theta? Tan 90 plus theta is equal to minus cot theta. Tan 90 plus theta is equal to minus cot theta. So we use this identity to reduce this particular term. Minus cot theta minus 35 plus cot 35 minus theta. Again, what is sin 90 plus theta? Sin 90 plus theta is equal to cos theta. So I can write 1 divided by cos theta minus 15 minus 1 by cos 15 minus theta plus cot theta minus 35. And this I can write as cot theta minus 35. I am taking negative sign outside this so that we will have negative here and this will be reversing the positions. Why? Because cot minus theta is equal to minus cot theta. And that means these two terms will cancel out each other. Now we have only these two left. Now again you see we have the expression cos minus theta is equal to cos theta. That means I can rewrite this expression as 1 by cos theta minus 15 minus 1 by cos theta minus 15. So this way I transform into this particular form. Both will result in the same value, and now we have two identical terms. I can cancel out and the overall answer of the expression will be 0 or option B. Given that sin theta is equal to A by B, then cos theta is equal to, again a simple problem. So it's given sin theta is equal to A by B. So I can construct a right angle triangle, and if this is theta, then I can write this to be A, B, and let this be a capital A, B, C. So what is the value of AB? AB will be equal to square root of B square minus A square. That means cos theta will be equal to AB by AC, or nothing but root B square minus A square divided by B. Option C. If cos alpha plus beta is equal to 0, then sin alpha minus beta can be reduced to, we have 4 options. Again in this problem, we do not know the value of alpha and beta, and therefore we cannot actually evaluate the value of sin alpha minus beta. So the way we have to think is that how can I convert this cos alpha plus beta into the required form of sin alpha minus beta. Let's do that. It's given cos alpha plus beta is equal to 0. What does this mean? This means that alpha plus beta is equal to 90 degree. Okay, clear? Because we know that cos 90 equal to 0. If cos alpha plus beta is equal to 0, that means alpha plus beta is equal to 90 degrees. Now I will manipulate this equation. I can write as alpha is equal to 90 minus beta, or alpha minus beta is equal to 90 minus beta, or alpha minus beta is equal to 90 minus 2 beta. Now we have to do sin alpha minus beta is equal to sin 90 minus 2 beta, and what is sin 90 minus theta? Sin 90 minus theta is equal to cos theta. That means this expression is equal to cos 2 beta. Therefore the answer is option C, or cos 2 beta. the value of tan 1 degree into tan 2 degree into tan 3 degree all the way up to tan 89 degree is, see, right from the start we can understand that there is no way we can evaluate by substituting the values of tan 1 degree or tan 2 degree and so on. We do not know this. If you really want these values, we will have to manually construct a triangle and calculate it, or we have to use a calculator, both of which are not possible from an exam point of view. So we have to convert this expression into a form which is simpler and possibly we can evaluate it. Let's do this. So we have the expression as tan 1 degree multiplied by tan 2 degree multiplied by tan 3 degree all the way up to tan 89 degree. Now I'll convert this into sin theta and cos theta terms. That means I'll get sin 1 degree by cos 1 degree, sin 2 degree by cos 2 degree into sin 3 degree by cos 3 degree all the way up to tan 89. Now what I will do is that I will make use of two identities, that is sin 90 minus theta is equal to cos theta, cos 90 minus theta is equal to sin theta. Remember, we are going to use these two relationship in this particular expression. So sin 1 degree I can write as sin 90 minus 89 divided by cos 90 minus 89 multiplied by sin 2 degree I can write as sin 90 minus 88 divided by cos 90 minus 88. Okay, sin 3 degree I can write as sin 90 minus 87 degrees divided by cos 90 minus 87 and all the terms up till sin 90 minus 46 divided by cos 90 minus 46 into sin 45 divided by cos 45 into, I'll write the terms here. Okay, now I will just write the value as it is. So sin 46 divided by cos 46, okay, into sin 47 by cos 47 into all the terms up till all the way up to sin 89 divided by cos 89 degree. Now we have sin 90 minus theta is equal to cos theta and cos 90 minus theta equal to sin theta, and I'll apply it to each of these terms all the way up till here. Okay, from sin 45 by cos 45 to sin 89 by cos 89, I'll keep the terms as it is without any change. So I will get this to be cos 89 degree divided by sin 89 degree into cos 88 degree divided by sin 88, like that all the terms up till cos 46 divided by sin 46 into sin 45 by cos 45 into sin 46 by cos 46 all the way up to sin 89 by cos 89. Now we can cancel out terms, cos 89 here, cos 89 here, sin 89 here, sin 89 here. Similarly, we have cos 88 here and cos 88 here, sin 88 here, sin 88 here, and you go all the way, all the terms will get cancelled out. Then you can see cos 46 is cancels out, sin 46 cancels out, remaining you will only have sin 45 by cos 45, and that will be tan 45, and tan 45 is nothing but 1. So the answer to the given question is option B, or 1. If cos 9 alpha is equal to sin alpha and 9 alpha is less than 90 degrees, then the value of tan 5 alpha is, how do we solve this? So it's given that cos 9 alpha is equal to sin alpha and 9 alpha is less than 90 degrees. When will cos and sin equate together? We know cos 45 is equal to sin 45. In that case, both the degrees were same as 45, but in this case we have different angles, that is one is 9 alpha and other is simply alpha. So when can cos and sin be same? Definitely alpha is not 45, right? We know cos 45 is equal to sin 45, but here that cannot be happening, right? Because we have 9 alpha here and alpha here. So what we could do, or what we can see, is that we can write, we know cos 90 minus theta is equal to sin theta. Now let us equate these two equations, that is I will equate these two terms and I will also equate these two terms. So sin theta is nothing but sin alpha and cos 9 alpha is nothing but cos 90 minus theta. That means I can write 90 minus alpha is equal to 9 alpha, or 90 is equal to 10 alpha, or alpha is equal to 9 degrees. That means tan 5 alpha will be nothing but tan 9 into 545, or tan 45 degrees, or simply 1. So the answer is option C. Any doubt here? See, we know cos 90 minus theta is equal to sin theta, and in the question we have cos 9 alpha is equal to sin alpha. So I can write this equation as cos 90 minus theta is equal to sin theta is equal to sin alpha. That means theta is equal to alpha, and that is how I wrote this equation. That is 90 minus theta now will become same as 90 minus alpha. If triangle ABC is right angled at C, then the value of cos A plus B is equal to, we have a right angle triangle A, B and C, right angled at C. Now we can write angle A plus angle B will be equal to 180 minus angle C, or nothing but 90 degrees, right? So what will be the value of cos A plus B? Is nothing but cos 90 degree, or 0. That is option A. If sin A plus sin square A is equal to 1, then the value of the expression cos square A plus cos to the power 4A is equal to, again a simple problem. It's given that sin A plus sin square A is equal to 1. That means sin A is equal to 1 minus sin square A, or sin A is equal to cos square A. Okay, we have to evaluate cos square A plus cos to the power 4A is equal to, we have cos square A, or cos square A same as sin A, and I will use this to rewrite this particular expression. I can write sin A plus sin square A. Okay, once more what I did, cos square A I can write as sin A, and cos to the power 4A I can write as sin square A, and we know that sin A plus sin square A is equal to 1 from this original expression. So the value of the expression is simply 1, or option A. Given that sine alpha is equal to 1 by 2 and cos beta equal to 1 by 2, then the value of alpha plus beta is, again a simple problem, sine alpha is equal to 1 by 2, cos beta is equal to 1 by 2. From these two, we can directly say that alpha will be equal to 30 degrees and beta will be equal to 60 degrees. And therefore, alpha plus beta is nothing but 90 degrees. So the answer is option D. The value of the expression sin square 22 plus sin square 68 divided by cos square 22 plus cos square 68 plus sin square 63 plus cos 63 sin 27 is, again, we cannot evaluate this expression because we do not know the value of sin 22 or sin 68 or sin 63 and so on. So we will have to simplify this expression into a simple form. Let's do that. So I can rewrite as sin square 22 plus, I will make use of the relation sin 90 minus theta is equal to cos theta. So sin square 68 I can write as sin square 90 minus 22 divided by, again, cos square 22 plus, I can write cos square 90 minus 22 plus sin square 63 plus cos 63 into sin 90 minus 63. Now this will become sin square 22 plus cos square 22 divided by cos square 22 plus sin square 22 plus sin square 63 plus cos square 63. Why? The sin square 90 minus 22 will become cos square 22. Similarly, cos square 90 minus 22 will become sin square 22, and sin 90 minus 63 will become cos 63. So we will have cos 63 into cos 63 and that will become cos square 63. Now this will add to 1, this will add to 1, and these two will come to be again 1. So we have 1 plus 1, or simply 2 as the value of the expression. So the answer is option B. If 4 tan theta is equal to 3, then 4 sin theta minus cos theta divided by 4 sin theta plus cos theta is equal to, again a simple problem. So we have tan theta is equal to 3 by 4. So the expression given is 4 sin theta minus cos theta divided by 4 sin theta plus cos theta. So this I can write as 4 tan theta minus 1 divided by 4 tan theta plus 1, or simply 4 into 3 by 4 plus 1 divided by 4 into 3 by 4 plus 1. Sorry, this will be minus. So this will come to be 1 by 2. So the answer is option C. If sin theta minus cos theta is equal to 0, then the value of sin power 4 theta plus cos power 4 theta is equal to. Again, easy question. It's given that sin theta minus cos theta is equal to 0. What does this mean? This means that sin theta is equal to cos theta. When will be sin theta equating to cos theta? That will only happen when theta is equal to 45 degrees. Therefore, I can write sin power 4 theta plus cos power 4 theta is nothing but sin theta is nothing but sin power 45 degrees plus cos power 45 degrees. So this is equal to 1 by root 2 whole power plus 1 by root 2 whole power, and this is equal to 1 by 2. Or option C, sine 45 plus theta minus cos 45 minus theta is equal to, and we do not know the value of theta, but I can write as sine 45 plus theta minus cos 45 minus theta is equal to sine, I'll rewrite this as sine plus theta minus 45 minus cos theta minus 45. See, I did two things. One, I converted this 45 plus theta into the form 90 plus theta minus 45, and this will be same. And I converted cos 45 minus theta into cos theta minus 45. Why? Because we know that cos minus theta is equal to cos theta. So I used this relation. Now this will come to be cos theta minus 45 minus cos theta minus 45, or simply 0 is the answer, or option B. A pole 6 meter high casts a shadow 2 root 3 meters long on the ground. Then the sun's elevation is. So this is the pole height, and height is 6 meters. Shadow is 2 root 3. So here is the sun, this is the pole, and the shadow is falling onto the ground like this, forming a right angle triangle. This is the shadow of the pole. So what is the angle of elevation? So angle of elevation theta we can write as tan theta is equal to 6 by 2 root 3, or nothing but 3 by root 3 or root 3. And when will tan theta becomes root 3? That will become when theta is equal to 60 degree. So the answer is option A. True or false, and justify the answer. First question is tan 47 divided by cos 43 is equal to 1. Let's check this. So tan 47 degrees divided by cot 43 degree. So this I can write as tan 47 divided by cot 90 minus 47. And we know that cot 90 minus theta is equal to tan theta. So we use this and apply it here. We get tan 47 divided by tan 47, or simply 1. So the given expression is true, and we have justified it by this evaluation. The value of the expression cos square 23 minus sin square 67 is positive. Let's check this. So we have the expression cos square 23 minus sin square 67, and cos square 23 I can write as cos square 90 minus 67 minus sin square 67, and cos square 90 minus 67 is nothing but sin square 67. Why? Because cos 90 minus theta is equal to sin theta, and cos square 90 minus theta will become sin square theta. So I can write sin square 67 minus sin square 67, or simply 0. Therefore, the value of the expression cos square 23 minus sin square 67 is not going to be positive, it is simply 0. So the answer is false. The value of the expression sin 80 minus cos 80 is negative. Let's check this. Sin 80 minus cos 80 is equal to Sine 80 minus cos 90 minus 10. I can write sine 80 minus sine 10. Now we have to see what is this value. Okay, whether this value is going to be a negative value. When can this expression become negative? This can only happen when sine 80 is less than sine 10. If this is true, then this is true. That is, it will become a negative value. But we can see that as theta increases in value, the sine theta will also increase in value. That is, if theta is increasing from 0 degree all the way up to 90 degree, the value of sine theta, okay, will increase in this order. Or I can write sine 0 is less than sine 1 is less than sine 2, and like that it goes all the way up to sine 90. That means sine 80 will be greater than sine 10, or sine 80 is greater than sine 10, or simply it means that sine 80 minus sine 10 will always be positive. Square root of 1 minus cos square a into c square a is equal to tan theta. Again, simple problem. This I can write as, that is the LHS I can write as square root of 1 minus cos square a is nothing but sine square a into 6 square I can write as 1 by cos square a, or this is nothing but square root of tan square a, or simply tan a, and this is equal to the RHS. So the given expression is true. If cos a plus cos square a is equal to 1, then sine square a plus sine to the power 4a is equal to 1. I have already solved this equation in question number 79, so I will not repeat. It is same as question number 79, you can check. Tan theta plus 2 into 2 tan theta plus 1 is equal to 5 tan theta plus 6 square theta. Let's check this. I can write the LHS as, what I will do, I will take this LHS and I will expand it, and I will see whether this is equal to 5 tan theta plus 6 square theta. Let's do this. LHS is equal to, I will expand it, I will get 2 tan square theta plus tan theta plus 4 tan theta plus 2, and this is going to be, I'll combine these two terms, okay, and I'll combine these two terms. So 2 tan square theta plus 2 plus 5 tan theta, and 2 tan square plus 2 is nothing but 2 into tan square theta plus 1 plus 5 tan theta, and this is going to be 2 6 square theta plus 5 tan theta, and this expression is not equal to this expression. So the given question is false. If the length of the shadow of a tower is increasing, then the angle of elevation of the sun is also increasing. So I have the tower, shadow number 1, shadow number 2, so we have a tower AB, and it is casting two shadows at two different time intervals. At some point in time it have a shadow P1, and after some time P1 is increasing to P2 when the sun is moving from this position to this new position. Now the given question is, if the length of the shadow of the tower is increasing, that is P2 is greater than P1, then the angle of elevation of the sun is also increasing, that is theta 2 is greater than theta 1. So we have the question that length of the shadow of the tower is increasing, then the angle of elevation of the sun is also increasing. And from the figure we can see that theta 2 is actually less than theta 1. So the answer is false. But mathematically speaking, how do we prove it? We can write tan theta 1 is equal to AB divided by P1, and tan theta 2 is nothing but again AB divided by P2. Now I can write P2 as P1 plus, I will note this distance to be x and the height to be h. So let this AB be h and this extra shadow be x. So I can write P2 equal to P1 plus x. So let me rewrite tan theta 1 is equal to h by P1, tan theta 2 is equal to h by P1 plus x. Now we'll equate h from these two equations. I will get P1 tan theta 1 is equal to P1 plus x into tan theta 2. Tan theta 1 divided by tan theta 2 is equal to P1 plus x divided by P1. Now P1 plus x divided by P1, that will be definitely greater than 1 because both are P1 and x is a positive number. So P1 plus x divided by P1 will be greater than 1. That means we can write tan theta 1 divided by tan theta 2 is greater than 1, or it implies that tan theta 1 is greater than tan theta 2. Now when will this happen? This happens when theta 1 is greater than theta 2. Why? This is because as theta increase in value, tan theta increase in value. So when we say tan theta 1 is greater than tan theta 2, it implies that theta 1 is greater than theta 2. If a man standing on a platform 3 meters above the surface of a lake observes a cloud and its reflection in the lake, then the angle of elevation of the cloud is equal to the angle of depression on its reflection. So let us check whether this reasoning is correct or not. And it's important that we construct the right triangles representing this scenario. So this is the surface of the lake, okay, and this is the platform above which or on which the man is standing. And it is given that the height of this platform is 3 meters above the surface of the lake. Now he is going to observe a cloud and its reflection on the lake. Now let us check several cases or several ways students might solve this problem and might result in a wrong answer. And before all this, the fundamental thing that we have to understand is that whatever be the height of the cloud from the surface of the water or the surface of the lake, its reflection will be at a same depth below the surface of the lake. That means whatever is this height of the cloud above the surface of the lake, let this be h, at the same depth, okay, at same depth d equal to h, we will have its reflection. So this is something we have to keep in mind very clearly. So now let me plot the triangles. Now scenario 1, that is, we plot two triangles in such a way that the point of observation is on the surface of the lake. So this is the surface of the lake and the point of observation is at the surface of the lake. In this case, you can see this is the angle of elevation, I call it as theta 1, and this is the angle of depression, I call it theta 2. In this case, theta 1 will be equal to theta 2. Again, the point of observation is on the surface of the lake. But in this question, in this particular problem, a man is standing on the platform and observing the cloud. And the platform itself is something like 3 meters in height or 3 meters above the surface of the lake. And we know that the person also will have some height, okay? And when he observes the cloud, it will be at this eye point. So it will be something like this. There is one more way people might plot this triangles, that is from this point, that is from the top of the platform. So you can have angle of elevation and angle of depression like this. Fortunately, in this problem, you make a construction of triangles either from the top of the platform or from the point of the eyes of the person. Both ways you will get the correct answer. The most accurate depiction of the triangles would be from the point of eyes, that is from the head level of the person viewing the cloud and its reflection. So let us draw that. So I have the diagram. Let me explain it. The point of observation, that is from the head level of the person, will be at a height of h plus 3. Okay, this 3 meters is the height of the platform and this h is the height of the person. So the point of observation will be h plus 3 from the surface of the lake. And from the level of the head of the person, the cloud is at a position a units above the head level of the person. And from the surface of the lake to its reflection, it is at a depth d. Now I can say that d will be equal to a plus h plus 3. Let me write. This is the fundamental symmetry of the problem, that is the depth at which the reflection will be occurring will be at the same distance above the surface of the lake. This is the fundamental thing that we have to understand on reflections. The position at which the reflection would occur below the surface of the lake will be at the same distance from the surface of the lake. And theta 1 is the angle of elevation and theta 2 is the angle of depression. Now I can construct, or now I have two right angle triangles, and using these two triangles we will assess that whether the angle of elevation of the cloud is equal to the angle of depression of its reflection. Let us do that. So first I will do tan theta 1 and then I will do tan theta 2. And one more thing, what is this gap? Okay, this gap I will denote as P. Now I can write tan theta 1 is equal to A by P. Fine. And tan theta 2 I can write as D plus H plus 3 divided by P. Now I will isolate 1 by P from these two equations. So 1 by P is equal to tan theta 1 divided by A. And here 1 by P is equal to tan theta 2 divided by D plus H plus 3. Now I have a relation for 1 by P in terms of theta 1 and theta 2. So let me equate these two terms because both are equal to 1 by P. So tan theta 1 by A is equal to tan theta 2 divided by D plus H plus 3. Or I can write tan theta 1 divided by tan theta 2 is equal to a by d plus h plus 3. Now what is a? A, if I write in terms of d and h, I will use this relation. Okay, what will be the value of a? A will be d minus h plus 3, right? Let's do that. So I have a equal to d minus h plus 3. Now I'll substitute here. So I'll get tan theta 1 by tan theta 2 is equal to d minus h plus 3 divided by d plus h plus 3. Now look at this particular thing very clearly. What is h plus 3? H plus 3 is what I will do, I'll take this equation slightly upwards so that we can discuss along with the diagram. So this is the deduced equation. Now what is h plus 3? H plus 3 is the height of the point of observation and d is the depth at which the reflection is occurring. And we know that depth is always going to be much higher than the point of observation or the height of the point of observation. So d is always going to be greater than h plus 3, right? D will be always greater than h plus 3. I hope everybody is clear with this argument that d will always be greater than h plus 3. Now, if d is greater than h plus 3, what will be the behavior of this particular fraction? That is d minus h plus 3 divided by d plus h plus 3. This will be less than 1 or greater than 1. What will be the scenario? This is going to be less than 1. So this equation is going to be less than 1. That means tan theta 1 is less than tan theta 2. And we know in the case of tan theta, that is, as theta value increases in value, correspondingly tan theta will also increase in value. That means theta 2 will be a value higher than theta 1, or we can write theta 2 is greater than theta 1, or the angle of depression is greater than angle of elevation. So it is not equal. There is an inequality here. So the given question statement is wrong. The value of 2 sin theta can be a plus 1 by a, where a is a positive number and a not equal to 1. So let us check this. Now it is said that 2 sin theta can be a plus 1 by a. So we can write that 2 sin theta is equal to a plus 1 by a. And it is given that a is greater than 0 because a is a positive number and a is not equal to 1. So let us check whether this is correct or not. I will rephrase the original equation as sin theta is equal to 1 by 2 into a plus 1 by a. Okay. Now what I will do, I'll assume some values for a starting in the range between 0 to 1. Okay. And not equal to 0 and 1. And I assume a to be a value equal to 0.5. I am randomly assuming a to be 0.5. In such case, the value of the expression will be 1 by 2 into 0.5 plus 1 by 0.5. And this value will come to be how much? If you calculate, you will get 2.5 by 2. And 2.5 by 2 will be a value greater than 1. And secondly, let us assume a value between 1 to positive infinity, not including 1. And again, I'll assume a value of a to be 2.5. Again, a random guess. In such a case, the value of expression will be 1 by 2 into 2.5 plus 1 by 2.5. Now what will be the value? This will be 2.9 by 2. Again a value greater than 1. We know that sine theta can never be greater than 1, right? Sine theta will always be between -1 and 1. And here we are finding two examples or two values for A which follows this properties, and the resulting value of the expression or the resulting value of sine theta is coming to be greater than 1. So that means the given statement is false. Now wait, let us check this question once more. Okay, see, in the question it says the value of 2 sine theta can be a plus 1 by a, where a is a positive number and a not equal to 1. See the reading, check the statement or check the words clearly. The value of 2 sine theta can be a plus 1 by a. That means just because two numbers didn't satisfy the above equation, just like what I did just now, we cannot say that it will be a false statement for all the numbers. Once more, just by proving that okay, for two particular numbers that this equation is not true, we cannot say that the given equation is false for all values for a. Okay, for this what we have to do, we have to show that for all values of a this equation is either true or false. We have to prove that, or we have to prove in such a way that for all numbers of a this particular equation is true or this particular equation is false. That's what, or that is how we have to solve this problem for its completeness. Let's do that. And there are many ways to prove this problem. I will use one particular method and show that whether this equation is true or false. Fine. We know that the value of sine theta will be between -1 and 1, and in the given problem we are asked about 2 sine theta. So we can write -2 less than or equal to 2 sine theta less than or equal to 2. Okay, what I did, I multiplied by +2 all across this equation. Since I am multiplying by a positive number, I don't have to change the sign, it will remain the same. So -2 less than or equal to 2 sine theta less than or equal to 2. Now you see, for any real number a, we can write a minus 1 whole square will be greater than or equal to 0. If I expand, I can write a square plus 1 minus 2a greater than or equal to 0, or a square plus 1 greater than 2a. Now in the given problem we have a to be greater than 0, that means a is definitely not 0 and a is also not equal to 1. But let us first consider this part, that is a greater than 0. If a greater than 0, what I can do, I can divide this entire equation by a. If I do that, I will get a plus 1 by a greater than or equal to 2. Fine. What is it we have to check in the problem? We have to check whether 2 sine theta is equal to a plus 1 by 2. That's the question. This is the question. Now when will this equation, or under what condition this will equate to 0, that is a minus 1 whole square equal to 0? That will happen when, see, a minus 1 whole square equal to 0, this will happen only when a equal to 1, and in the given problem we know that a is not equal to 1. That means this particular equation we can modify as a minus 1 whole square greater than 0. Now we have this proof that a minus 1 whole square is greater than 0. That means we can write this equation will be modified to a plus 1 by a greater than 2. Now we obtain that a plus 1 by a is greater than 2, and we know that 2 sine theta will be always less than 2. Now does it satisfy this equation? On one side we have 2 sin theta, and we know that 2 sin theta will be always less than 2, and on the other side we have a plus 1 by a, and we know that a plus 1 by a is always greater than 2. So for any real number a such that a is greater than 0 and a not equal to 1, we will not be able to have this equation matching. Hence the given statement is, or the given question is, false. This is the correct way to solve the problem, where we checked for all values of a. Cos theta is equal to a square plus b square divided by 2ab, where a and b are two distinct numbers such that ab is greater than 0. Let's solve this. Just like the previous problem that we discussed with respect to some sin theta, this is again a tricky problem, a very interesting problem, and actually we can complicate this problem very easily, and it could be a very good question which is capable of coming into a IIT JEE paper or any competitive exam, because there is a lot of fundamental knowledge that one has to know to solve this problem. So from that perspective, this is a very good question. For the first time, when somebody sees this question, you may feel that okay, this is a simple question, I can put some numbers and I can solve this, but fundamentally this is a very good question, and I would like all of you to pay very good attention on how we are solving this problem and what is the underlying principles with which we are going to solve this problem, because in future we will be applying similar principles on other problems. So we have cos theta equal to a square plus b square divided by 2ab, and it is given that a and b are distinct numbers. That means we can write a is not equal to b and the product ab is greater than 0. Now what is the first thing that we know? The first thing that we know is that minus 1 less than or equal to cos theta less than or equal to 1. This is a fundamental knowledge that all of you should know, and we start from this particular point. Now another aspect that we have to understand is that for this to be true, what we have to check is that for any number a and b, this has to be true. Again, for any number that we can think for a and b such that a is not equal to b and ab greater than 0, this statement has to be true. That is what we have to check. Some of you may substitute some numbers and check, okay, cos theta is not equal to this, and therefore this statement is true or this statement is false. When you do that, okay, you will get some idea about the behavior of this equation, but we cannot mathematically say with confidence and clarity that this statement is true or false. For that, we have to prove in such a way that for any number a and b, this statement has to be say true or false. Now we know that for any two real numbers a and b, we can write, observe, a minus b greater than or equal to 0. This will be true for any two real number a and b, and a minus b whole square greater than 0. How did I come from this to this? When will this relation will become in such a way that a minus b whole square equal to 0? That will only happen when a equal to b. Now it is given that in the question that a is not equal to b. So since a is not equal to b, the only condition will be a minus b whole square greater than 0. Fine. Now I can write a square plus b square minus 2ab is greater than 0, or I can say a square plus b square is greater than 2ab. It's given that ab is greater than 0, so we can divide by 2ab in this equation, And since AB is greater than 0, that means AB is a positive number. So we can divide by 2AB and without changing the sign. A square plus B square divided by 2AB is greater than 1, and let this be equation 1. And we also know that minus 1 less than or equal to cos theta less than or equal to 1, and let this be equation 2. Now if you observe equation 2 and equation 1, does this go hand in hand? We can see that on one side a square plus b square divided by 2ab will be a value always greater than 1, and we also know that cos theta can only be less than or equal to 1. That means these two doesn't match each other. In other words, the given statement that cos theta equal to a square plus b square by 2ab is not correct. It's a false statement. Once more, equation 1 and equation 2 doesn't go hand in hand. It doesn't match each other, and therefore we can say that the given statement is false. The angle of elevation of the top of a tower is 30 degree. If the height of the tower is doubled, then the angle of elevation of its top will also be doubled. This we can solve by directly constructing a diagram. So now we have a tower of height h with an angle of elevation equal to 30 degree. Now I am doubling the height of the tower. So I have one more tower here. Let's draw this. And we will keep the distance from the bottom of the tower to the point of observation to be w. Now I can write tan 30 is equal to h by w, and tan theta is equal to, again this will be h, so tan theta is equal to 2h by w, or 2 into tan 30. So tan theta is equal to 2 into 1 by root 3 or 2 by root 3. Now as said in the problem, if the height of the tower is doubled, then the angle of elevation, okay, will also double. That is, from 30 it will double to theta equal to 60 degree. But what is tan 60? Tan 60 will be just root 3, right? Tan 60 will be equaling root 3, and this is not equal to 2 by root 3, which is tan theta. So this means that angle of elevation will not double in value when the height of the tower is doubled. Therefore, the given statement is false. If the height of a tower and the distance of the point of observation from its foot both are increased by 10%, then the angle of elevation of its top remains unchanged. Again, we will solve this by constructing a figure. So I have a tower and the angle of elevation from the point of observation is this. So let it be theta, h and theta. Now the height of the tower and the distance of the point of observation from the foot both are increased by 10%. Now what will happen? So we have a slight increase in the tower height and slight increase in the point of observation, and let this be theta 2 and the original one be theta 1. So tan theta 1 is equal to h by w, and tan theta 2 will be equal to h plus this particular value, that is 10% of h. So I can write as 0.1 h divided by w plus this particular distance, that will be 10% of w, or 0.1 h. So this is nothing but 1.1 h divided by 1.1 w, or simply h by w. Now I can equate this equation and this equation. So I will get tan theta 1 is equal to h by w is equal to tan theta 2. That means theta 1 is equal to theta 2. So the given question is correct, that is the angle of elevation of its top will remain unchanged. Prove the following: sin theta divided by 1 plus cos theta divided by 1 plus sin theta is equal to 2 cosecant of theta. So LHS I can write as LHS equal to, I will do cross multiplication. Okay, so I'll get sin square theta plus 1 plus cos square theta plus 2 cos theta divided by sin theta into 1 plus cos theta. Now I have sin square theta and cos square theta, so I'll add up, I'll get 1, and I have another 1 here, so together I'll get 2. That means 2 plus 2 cos theta divided by sin theta into 1 plus cos theta. So I'll get 2 into 1 plus cos theta divided by sin theta into 1 plus cos theta, or simply 2 by sin theta, which is equal to 2 of cosecant of theta, which is equal to RHS. Thus proved. Again I'll start by solving the LHS. So LHS is equal to, again I will do cross multiplication. I will get tan A minus tan A secant of A minus tan A minus tan A secant of A divided by 1 minus 6 square A. Now I can cancel out these two terms and I can add these two terms. So I'll get minus 2 tan A secant of A divided by 1 minus 6 square A. Now we know that tan square A plus 1 is equal to 6 square A. So I will use this relationship here, that is minus 2 tan A secant of A divided by minus tan square A, and this will come to be 2 secant of A divided by tan A, or 2 into 1 by cos A into cos A divided by sin A, or simply 2 by sin A, or 2 cosecant of A. Okay, so now we have proved that LHS to be same as RHS. Sorry, this is not theta, this is A, 2 cosecant of A. If tan A is equal to 3 by 4, then sin A cos A is equal to 12 by 5. We have to prove this. Let's see. I can construct a triangle and I will name it A, B and C, and it's given tan A is equal to 3 by 4. That means this is 3, this is 4, and we know that AC will be equal to 5. Now I can write sin A to be 3 by 5 and cos A to be 4 by 5. So the given question, the value of sin A cos A will be equal to 3 by 5 into 4 by 5, or nothing but 12 by 25. Hence proved. Sin A plus cos A into tan A plus cot A is equal to secant of A plus cosecant of A. Let's do this. What I would do is that I will take the LHS and try to equate or try to make it to the RHS form. Let's do that. So LHS is equal to, and I will multiply everything together. I will get sin alpha into tan alpha plus sin alpha into cot alpha plus cos alpha into tan alpha plus cos alpha into cot alpha. Now I will convert every tan alpha, cot alpha in terms of sine and cosine. I will get sine square alpha by cos alpha plus cos alpha plus sine alpha plus cos square alpha by sine alpha. So I can write, if I make a common denominator, I can write sine cube alpha plus sine alpha cos square alpha plus sine square alpha into cos alpha plus cos cube alpha whole divided by sine alpha cos alpha. I will isolate sine alpha from these two terms and I will isolate cos alpha from these two terms. So I can write sine alpha into sine square alpha plus cos square alpha plus cos alpha into sine square alpha plus cos square alpha whole divided by sine alpha cos alpha. Now this term is nothing but 1. Again, this term again will be nothing but 1. So I can write sine alpha plus cos alpha divided by sine alpha cos alpha, or nothing but, if I separate these two terms, term number 1 is this and term number 2, I will get 1 by cos alpha plus 1 by sine alpha, or secant of alpha plus cosecant of alpha, and this is nothing but the RHS. Thus root 3 plus 1 into 3 minus cot 30 is equal to tan cube 60 minus 2 sine 60. Let's do this. The way I would do or solve this question will be, see, we know all these values, sine 60 I know, tan 60 I know, cot 30 is nothing but again tan 60, and since we know all these individual values, it is better to evaluate both LHS and RHS separately and try to prove that they are same. Let's do that first from LHS. So LHS is nothing but root 3 plus 1 into 3 minus cot 30 is nothing but tan 60. Why? Cot 30 I can write as cot 90 minus 60, and this is equal to tan 60. So I will use this and substitute here tan 60, and this will be root 3 plus 1 into 3 minus root 3. I will open the brackets. I will get 3 root 3 minus 3 plus 3 minus root 3, or nothing but 2 root 3. Now let us check the RHS. RHS equal to tan cube 60 minus 2 sine 60. Now tan 60 is root 3. So root 3 whole cube minus 2 into sine 60 is nothing but root 3 by 2. So this is nothing but root 3 into root 3 into root 3 minus root 3. This 2 and 2 will cancel out, and this is nothing but 3. So I can write 3 root 3 minus root 3, or nothing but 2 root 3. So we have both LHS, that is this, and RHS, this is this, both becoming same, hence proved. 1 plus cot square alpha divided by 1 plus cosecant of alpha is equal to cosecant of alpha. Let's do this. I'll start with the LHS. Okay. So LHS is equal to 1 plus, for cot square alpha, I will use the identity, that is cot square alpha is nothing but cosec square alpha minus 1, right? So this I can write as cosec alpha minus 1 into cosec alpha plus 1. So I will use this here. Cosec alpha minus 1 into cosec alpha plus 1 divided by 1 plus cosecant of alpha. Now this term and this term cancels out, and this plus 1 and minus 1 will get cancelled out, leaving only with cosecant of alpha. Now this is nothing but the RHS, thus proved. Tan theta plus tan 90 minus theta is equal to secant of theta into secant of 90 minus theta. Let's do this. In this problem, what I would do, I will take both the LHS and RHS and I'll convert both individually into terms of sine and cosine. Let's do this. So LHS is equal to sine theta divided by cos theta plus, what is tan 90 minus theta? Tan 90 minus theta is nothing but cot theta, and cot theta now I will write in terms of sine and cosine. Cos theta divided by sine theta. So this will be sine square theta plus cos square theta divided by sine theta cos theta. Oops, this is theta. So this will be 1 by sine theta cos theta. Why? Because this will be 1 and that is this. Now I will move to the RHS and try to simplify it. RHS is now secant of theta is nothing but 1 by cos theta. Okay. And what is secant of 90 minus theta? Secant of 90 minus theta is nothing but cosecant of theta. And this again write as 1 by cos theta into 1 by sin theta, or nothing but 1 divided by sin theta cos theta. Again we have LHS coming same as RHS, thus proved. Find the angle of elevation of the sun when the shadow of a pole h meters high is root 3 h meters long. Let me first construct the right angle triangle. So height of the pole is h and the shadow of the pole is root 3 h. Let this be A. Now what is the angle of elevation? That is nothing but tan theta is equal to h by root 3h, or nothing but 1 by root 3. Now when will tan theta equal 1 by root 3? That will be when theta is equal to 30 degree. Implies theta is equal to 30 degree, which is the answer. See, to solve these kind of problems, one has to be very thorough or very comfortable in finding the values of these trigonometric terms for the basic angles, that is theta equal to 30, 45, 60, all these values should come to your mind very comfortably. So in a way, either you have to memorize it or find some trick depending upon how you study, but you need to know this. So this is kind of expected of you, that you know all these values so that you can solve these kind of problems. See, this is a very simple problem, but in the exam, if you do not know at what theta will this become 1 by root 3, then you will not be able to write this particular statement, or you will not be able to find that theta equal to 30 degree. So such a simple problem, just because you don't know the value of tan theta equal to 1 by root 3, you will not be able to write this. So solve more problems and get comfortable with this. If root 3 tan theta is equal to 1, then find the value of sine square theta minus cos square theta. Let's do this. So it is given that root 3 tan theta is equal to 1, or tan theta is equal to 1 by root 3. Now when will tan theta equal to 1 by root 3? That will happen when root 3 is equal to 30 degree. Okay. Then I can evaluate the given question, that is sin square theta minus cos square theta. This is nothing but sin square 30 minus cos square 30. Now what is sin 30? Sin 30 is nothing but 1 by 2, and I have a whole square, minus cos 30 is nothing but root 3 by 2. Again I have a whole square. So if I evaluate, I will get 1 by 4 minus 3 by 4, or nothing but minus 1 by 2. So this is the value of the expression sin square theta minus cos square theta given the condition root 3 tan theta equal to 1. A ladder 15 meters long just reaches the top of a vertical wall. If the ladder makes an angle of 60 degree with the wall, find the height of the wall. So let us first construct the triangle. I have a ladder, and the ladder just reaches the top of a vertical wall. So this be the vertical wall. I will join these 2 points. Now it's given that the ladder is 15 meters long and it makes an angle 60 degree with the wall. So this is 60 degree. We have to find the height of the wall. So the common mistake here will be, instead of placing 60 degree here, some people out of hurry will put 60 here and you will get the wrong edge and probably no marks. So read the question very clearly so that you mark the correct angle. Now, which trigonometric function I can use to relate h and 15? I can use cos 60. So what will be cos 60? Cos 60 will be equal to adjacent divided by hypotenuse, that is h divided by 15. And what is cos 60? Cos 60 is nothing but 1 by 2. That means h is equal to 15 by 2, or 7.5 meters long. Simplify 1 plus tan square theta into 1 minus sin theta into 1 plus sin theta. Let's do this. What we have to do, we have to simplify this. Let's do this. I will make use of the relation 1 plus tan square theta is nothing but 6 square theta. So this is nothing but 6 square theta into, this is nothing but 1 minus sin square theta. How? This is nothing but a minus b into a plus b, and you will get a square minus b square. This I can further write as 6 square theta into cos square theta, or nothing but 1. So on simplification we will get this expression to be 1. If 2 sin square theta minus cos square theta is equal to 2, find the value of theta. So it's given that 2 sin square theta minus cos square theta is equal to 2. So I can write as 2 sin square theta minus 2 is equal to cos square theta, or nothing but 2 into sin square theta minus 1 is equal to cos square theta, and this I can write as 2 into minus cos square theta is equal to cos square theta, or nothing but 0 is equal to 3 cos square theta. Now when you look at this particular expression, 3 can never be 0, so the only possibility is cos square theta is equal to 0, implies cos square theta is equal to 0, implies cos theta into cos theta is equal to 0. See, we understood that cos square theta is equal to 0, and when you expand you will have cos theta into cos theta equal to 0. That means cos theta is equal to 0. Now when will cos theta equal to 0? That can happen only when theta is equal to 90 degree. Some of you may wonder why I went so long writing all these steps just to get to this answer. Right from here you will be thinking, okay, 3 can never be 0, that means cos square theta is 0, and that means theta equal to 90 degree. It is perfectly correct. I wanted to stress this approach because sometime later you will see problems where it is very important that we don't directly jump over steps but go step by step in getting the answer, because we might miss out some features or some solutions just by cutting it off. This might sound confusing for some of you, but don't worry. Right now, I know all of you will be clear about this solution. When such kind of problems arrive, I will tell in detail why we have to explicitly expand all the terms and get to the solution rather than directly jumping from this to here. A bag contains 10 red, 5 blue and 7 green balls. A ball is drawn at random. Find the probability of this ball being a red ball, green ball and not a blue ball. Okay. So I have 10 red balls, 5 blue balls and 7 green balls. Okay. Now I have to find the probability of finding a red ball. So what are the total number of balls available? That will be 10 plus 5 plus 7. That is, the total balls in the bag will be 10 plus 5 plus 7 or 22 balls. This means that we have 22 possible outcomes when we pick a ball randomly from the bag. Once more, I have 22 possible outcomes when I pick a ball randomly from the bag. Okay. The first question is that what if it is a red ball? Okay. So probability of a red ball is going to be, I have totally 22 possible outcomes in which 6 are the favorable one, and that means it is going to be 10 by 22. 10 by 22 or nothing but 5 by 11. Fine. Next is probability of a green ball. Again, I have 22 possible outcomes in which 7 favorable outcomes are there. So the probability this will be 7 by 22. 7 by 22, and it is already in the smallest fractional form, or 7 and 22 form a coprime. Just for all of you to brush up your memory. Okay. And the last probability that it is not a blue ball. What does this mean? This means that it can be anything else, right? It can be anything other than a blue ball, or it can be a red or a green ball. And that will be 10 plus 7, 10 plus 7, 17 favorable outcomes out of 22 possible outcomes. So it's going to be 17 by 22. So we have the 3 answers for the given question. The king, queen and jack of clubs are removed from a deck of 52 playing cards and then well shuffled. Now one card is drawn at random from the remaining cards. Determine the probability that the card is a heart, a king, a club and 10 of hearts. In a deck of cards, we will have 13 hearts, 13 clubs, 13 diamonds and 13 spades. I hope all of you are familiar with these symbols and playing with cards. I used to play cards a lot and I really love it. But don't play cards by putting life in danger. These days people are doing it. Don't do that. Play cards just for the fun of it with your friends. Don't play with your life. Okay. So in this problem, it is said that king, queen and jack of clubs are removed. That means what are the total number of cards available with us now? Once we remove these 3 cards of clubs, I will have 13 plus 10 plus 13 plus 13. Okay. So that will be 13 plus 10 plus 13 plus 13 equal to 49. So in this particular problem, I have only 49 possible outcomes when I pick a card randomly from the pack of cards. Now the first question is that what is the probability that it is a heart? So what is the probability of it being a heart? See, I have still 13 hearts available with me out of 49 possibilities. So it is going to be 13 by 49. Fine. The probability will be 13 by 49. Again, 13 is a prime number. Therefore, 13 and 49 will form a coprime. Second, probability of a king. What is the probability for a king? See, I have one king in the set of hearts, one king in the set of diamonds, and one king in the set of spade. I had one king, but now I have removed it. Okay, so there are only 1 plus 1 plus 1, 3 kings available with me, and totally there are 49 possible outcomes. So the probability will be 3 by 49. And next, probability of a club. Again, initially I had 13 cards available of clubs, and I removed king, queen and jack. So that means I have now 10 clubs with me, right? So the probability will be 10 by 49. And last, probability that the card is 10 of hearts. There is only going to be one 10 of hearts out of 49 possible outcomes. So the probability will be 1 by 49. An integer is chosen between 0 and 100. What is the probability that it is divisible by 7 and not divisible by 7? Let's do this. So to check numbers between 0 and 100 that are divisible by 7, we have to find the multiples of 7 between 0 to 100. I repeat, to find the numbers that are divisible by 7, what we have to do? We have to find the multiples of 7 between 0 and 100. And you can observe that the extreme numbers between 0 and 100 that is divisible by 7 will be 7 and 98. And what we can see is that all numbers which are divisible by 7 and that lies between 7 and 98, it will form an arithmetic progression. So we can use the relations from arithmetic progression to solve this problem. Let's do this. So I can write an is equal to a1 plus n minus 1 into d, and an is 98, a1 is 7 plus n minus 1 into the common difference is again 7. So you will get 91 is equal to n minus 1 into 7, or 13 is equal to n minus 1, or you will get n equal to 14. So there are 14 numbers which are divisible by 7 that lies between 0 and 100. No, but in this problem, this arithmetic progression method may not be required. Why? Because 98 is still a small number, and we immediately know that 7 into 14 is 98. That means there are 14 numbers divisible by 7 between 0 to 100. But this arithmetic progression method will be very helpful when we are dealing with very large numbers. Let's say in the exam or in the question we have a very large number, then we will not be able to quickly identify this multiple. So in that scenario, this arithmetic progression is a much simpler method in getting the number of numbers that are divisible by a certain factor. So from a general point of view, this is the safest method. Now let's find the probability of numbers divisible by 7. So I have 14 number as favorable outcomes. And what are the total number of possibilities? That is total number of numbers between 0 to 100, 99. Again, a lot of students will make mistake here. They will write 14 by 100, and that's wrong. See, in the question it is clearly says that an integer is chosen between 0 and 100. That means 0 and 100 both are not included in this problem. We need only the numbers between 0 and 100, and that will be 99 numbers. So most of the people will make the mistake in the denominator. Now the second problem, probability of numbers not divisible by 7. This will be simply 1 minus 14 by 99, or you will get 85 by 99. How are we writing this? Because these two probabilities will be complementary, right? We first found out numbers which are divisible by 7 between 0 to 100. That means all the other numbers will be not divisible by 7. So simply the probability of not divisible by 7 will be simply the complementary of probability of numbers divisible by 7. Hence, I am writing 1 minus 14 by 99, and the final answer is 85 by 99. Cards with numbers 2 to 101 are placed in a box. A card is selected at random. Find the probability that the card has first an even number and second a square number. The first thing is that we have to find the probability that the card has a even number. That means I have to find the number of even numbers between 2 to 101. So I will use arithmetic progression to find the number of even numbers between 2 to 101. Again, I have an is equal to a1 plus n minus 1 into d. So the last even number between 2 to 101 will be 100, and that will be an, and the first number is simply 2, and the common difference is again 2. So I can write 100 is equal to 2 plus n minus 1 into 2, and once you solve you will get 98 is equal to n minus 1 into 2, or simply n is equal to 50. So there are 50 even numbers in the range 2 to 101. So I can write the probability as probability of an even number will be, so the favorable outcomes will be 50 divided by the total number of outcomes will be the total numbers from 2 to 101, and that is 100 numbers, or the probability is 1 by 2. And the second question is a square number. Again, the total range of number is 2 to 101. Now what we have to check is that the perfect squares from 2 to 101. So the smallest square possible is 4 and the largest square possible is 100, right? So I have the smallest square as 4 and the largest square as 100, and they are correspondingly 2 square and 10 square. So how many numbers are there which are perfect square from 2 to 101? That will be 2, 3, 4, 5 all the way up to 10, and that is simply 9 numbers. So the required probability is favorable outcomes are simply 9 divided by the total number of possibilities, that is 100, or simply 9 by 100. A carton of 24 bulbs contain 6 defective bulbs. One bulb is drawn at random. What is the probability that the bulb is not defective? And a secondary question, if the bulb selected is defective and it is not replaced, and then a second bulb is selected at random from the rest, what is the probability that the second bulb is defective? So what you can see here is the sample image representing the carton. See, I have not drawn all the 24 bulb here, okay? Only few of them I have drawn, just for all of you to have an idea about the problem. And now the Green bulb represent the bulbs that are perfectly fine, and the red ones represent one which are defective. So totally we have 24 bulb, and out of which there are 6 defective ones. Okay. Now I'm randomly selecting one bulb from the carton. So what is the probability that it is not defective? That is the first question. What is the probability that the bulb is not defective? Let's do this. So I have 24 bulb and 6 are defective. Now what is the probability of bulb not defective? That will be the total number of bulb which are perfectly fine divided by the total number of bulb that are available to be selected in the carton box. So that will be 18 divided by 24. Again 18 is coming because out of 24 bulb 6 are defective. So I have 24 minus 6 or 18 bulb which are perfectly fine, and the total number of bulb is 24. Now the second question is that probability that the second bulb is defective, but we have an additional condition, that is the first bulb that we selected is defective and we have not replaced. What it means is that I have this carton and I have all the bulb in this. Now first I took a bulb and that is a defective bulb. Okay. What I did, I took this bulb outside the carton. Now that I have taken this bulb outside the carton, what is the total number of bulb available in the carton? That will be 24 minus 1. This 1 is simply this defective bulb. So now I have only 23 bulb in this carton box, and out of 23 bulb, how many defective will be there? There will be 5 defective bulb in the carton, because the sixth defective bulb is already outside the carton. So remaining 5 defective bulb will be in the carton. So what happens is that the new scenario will be I will have 23 bulb and out of which 5 are defective. Now the question is probability that the second bulb is defective. So that will be simply 5 divided by 23. Again, this 5 is the total number of defective bulb in the carton provided the first condition, that is the first bulb is selected which is defective and it is not replaced. Not replaced meaning it is now kept outside the carton. So in the carton I have only 23 bulb, and out of 23 bulb only 5 are defective because one defective bulb is already outside the carton. In a game, the entry fee is rupees 5. The game consists of tossing a coin 3 times. If 1 or 2 heads show, Shweta gets her entry fee back. If she throws 3 heads, she receives double the entry fees. Otherwise, she will lose. For tossing a coin 3 times, find the probability that she loses the entry fee, gets double entry fee, just gets her entry fee. So in this problem, the basic game is that we are tossing a coin 3 times. So when you toss a coin 3 times, what are the total possibilities or total outcomes? So tossing a coin 3 times, the total possibilities or outcomes are simply 2 into 2 into 2 or 8 outcomes. So this is the summary of the question. That is, when Shweta gets 1 or 2 hits, she will get her entry fee back. And if she gets 3 hits, then she receives double the entry fee. And for all other cases, she will lose the entry fee. So what will be the rest of the case? So what are the cases other than the first two? That is only the case when she gets 3 tails, right? Or simply 0 head. When you toss a coin 3 times, what are the possibilities? You can have 0 head, okay? I can have 1 head, I can have 2 heads, or I can have 3 heads, right? For 3 heads, we have a scenario that is she will receive double the entry fee. For 1 and 2 heads, we have a condition that she receives the entry fee back. So, the only case that is left is 0 heads. When she gets 0 heads, she will lose the entry fee, and that means, and 0 head means she gets 3 tails. Fine. Now the first question, that Shweta loses the entry fee, that is only when she gets 0 head or 3 tails. And what are the possibilities when she will get 0 heads or 3 tails? That is simply only one case. And the total number of possibilities 8. So the answer is 1 by 8. Second is probability she gets double entry fee, and that will only happen when she gets 3 head. Again, there is only one possibility when Shweta can get 3 heads out of 8. So it is simply 1 by 8. Now the last probability, she just gets her entry fee, and that will happen when she gets 1 or 2 heads. Now what are the total number of favorable outcomes for 1 or 2 heads? That will be simply 8 minus 1 divided by 8. How am I writing this? The total possibilities are 8. Okay. Now we have to see the number of cases when she gets 1 or 2 heads. So out of the total number of possibilities, I subtract the case when she gets 0 head. Okay. And then I subtract the case when she gets 3 heads. So that is this minus 1 and minus 1. Or basically what I did, 1 minus 1 by 8 minus 1 by 8. So the total probability is 1, out of which I subtracted the probability that she gets 3 heads and the probability that she gets 0 head. That will give me the probability that she gets 1 or 2 heads. And this answer will come to be 6 by 8 or 3 by 4. Now this approach of solving the problem, if it is difficult for you to think and do, then what you can do is that we can go the hard way. That is you write all the possible outcomes when you toss a coin 3 times. So that is this, we have 0 head or 3 tails. Okay. Now this is the case when I have 1 or 2 heads, and this is the case I have 3 heads. Now let's come back. Okay. The first question, probability that Shweta loses the entry fee. When will Shweta lose the entry fee? She will lose if she gets 0 head or 3 tail. Now when can this happen? The only possible outcome is this, that is she gets 0 head or 3 tails. So there is only one possible outcomes, and total we have 8 possible outcomes, or simply 1 divided by 8. Second question, probability that she gets the double entry fee back. Okay. When can Shweta get the entry fee back, that is double the entry fee back? That can only happen when she gets 3 heads. Okay. Now what are the possible outcomes or favorable outcomes for 3 heads? It is simply only one case. So only one case is favorable for Shweta, and that is this one. and the total possible outcomes are 8, right? These are the 8 possible outcomes. Now the last question, probability that Shweta just gets her entry fee back. That is only possible when she gets 1 or 2 hits. Now what are the cases when she will get 1 or 2 hits? That is simply these 6 cases. In each of these 6 cases, she will be getting 1 or 2 hits. So that is 6 cases, that is this, and the total possible outcomes are 8. So the probability is 3 by 4. A die has its 6 faces marked 0, 1, 1, 1, 6, 6. Two such dice are thrown together and the total score is recorded. How many different scores are possible and what is the probability of getting a total of 7? Let's do this. So we have a die and it has 6 faces, but the numbers are different. This time we have numbers like 0, 1, 1, 1 and 6 and 6. And two such dice are thrown together. Now when you throw two dice together, what will be the total possible outcomes? It will be depending on the number of faces. So we have 6 faces and therefore the possible outcomes will be 6 into 6 or 36. So we can have 36 possible outcomes. Now we have to check first of all how many different scores are possible. To do this, how can we do? We can see that on dice 1 and dice 2, the unique numbers that we have are 0, 1 and 6. Okay. Now we have to see what are the possible scores that can happen when we throw these two dice. So what can possible happen? On the first dice I can have 0, on the second dice I can have 0, that means I will get a score of 0. Then on the first dice I can have 0, on the second dice I can have 1, so the score will be 0 plus 1 or 1. Similarly on the first dice I can have 0, on the second dice I can have 6, so that means the score will be 0 plus 6 or 6. Similarly, I can have 1 0, that is one combination. I can have 1 1, I can have 1 6. Similarly, I can have 6 0 or 6 1 or 6 6. Now, out of these combinations, how many scores are possible? You can see that there are some duplications. These two will have the same score of 1, right? Similarly, these two will have the same score of 6. Again, these two will have the same score of 7. So the possible scores will be, I can have 0, 1, 6, 2, 7, 12. 0, 1, 6 come from these three combinations. 2 and 7 comes from these two combinations. I am neglecting this because this is same as this. 12 comes from the combination 6 and 6. Again, I am neglecting these two because these are already counted here. Therefore, in total, 6 different scores are possible when we throw two dice with the numbers 0, 1 and 6. Fine. In the NCERT textbook, it is said that 5 is the answer. Okay. But I think that is wrong. It is a typo error. The correct answer will be 6 scores are possible. Second part. What is the possibility of getting a total of 7? We already know the total possible outcomes are 36. Now what we have to check is the favorable outcomes in which I will get a total of 7. So when we check this particular thing, we can see that 7 will come when we have 1 6 or 6 1, right? These are the only two combinations which will result in a score of 7. Now is the answer 2 by 36? Why? Because I have two favorable outcomes and totally 36 outcomes. So the answer is 1 by 18. The answer is no. This is not the correct answer. Why? Because there are multiple times I can get 1 6 and there are multiple times I can get 6 1. These are not happening just once. So let's check this. Now observe clearly, right? For 1 6, that is on the dice 1 I get 1 and on the dice 2 I get 6. How many times this is possible? See, I can have 1 on the dice 1 and I can have 6 on the dice 2. Again the same situation I can have like this. Okay, is it over? No, I can still have a condition like this, 1 and 6 or 1 and 6. Similarly, I can have 1 and 6 and last again 1 and 6. So totally you will have 6 times. So totally 6 times I can have this particular combination 1 6. Now let us check 6 and 1. Now let us check 6 1, that is on the dice 1 I get 6 and on the dice 2 I get 1. Okay, so I can have 6 on the dice 1 and 1 on the dice 2. Again I can have 6 on the dice 1 and 1 on the dice 2. Again I can have like this. So I have 3 now, it's not over. Again I can have 6 1 6 1 6 1. So in total 6 times this is possible. Now I can write the probability. So probability of getting a total of 7 will be, for 1 6 I can have 6 times and for 6 1 I can have 6 times. So it will be 6 plus 6 or 12 favorable outcomes are there. That is, I can write 12 by 36 or 1 by 3. This is the final answer. A lot consists of 48 mobile phones, of which 42 are good, 3 have only minor defects and 3 have major defects. Varnika will buy a phone if it is good, but the trader will only buy a mobile if it has no major defect. One phone is selected at random from the lot. What is the probability that it is acceptable to Varnika and second, acceptable to the trader? Let's do this. So this is what the question says, that is, we have 48 mobile phones, out of which 42 are good, 3 have minor defect and 3 have major defect. Let us look at the first question, that is, what is the probability that it is acceptable to Varnika? So I will write like this, probability. First thing, what is the probability that it is acceptable to Varnika? When will Varnika buy a phone? She will buy a phone if it is in good condition. So I can have only 42 good mobile phones. She is not ready for minor defect or major defect. So her probability will be 42 divided by 48. 48 is the total possible outcomes, out of which 42 are favorable for Varnika. Now second, probability for the trader. The trader will select a phone only if it has no major defect. That means he is okay with the minor defect. So what will be the favorable outcomes for trader? It will be 42 plus 3. He is not ready for major defect. And the total possible outcomes are 48. So I can have answer as 42 plus 3 divided by 48. These are the answers. At a feat, cards bearing numbers 1 to 1000, one number on one card are put in a box. Each player selects one card at random and the card is not replaced. If the selected card has a perfect square greater than 500, the player wins a prize. What is the probability that the first player wins a prize, and second, the second player wins a prize if the first has won. Let's do this. This is the summary of the question. Cards have numbers 1 to 1000, and on one card we have only one number. Now each player will select one card at random, and this card is not replaced. That means once a player picks a card, it is not put back into the box. Again, once a player picks a card, he will not put it back into the box. Okay. Now, when will a player win a prize? He will win a prize if the card he has selected has a number that is a perfect square, and it should be greater than 500. So, the first thing that we have to find is the number of perfect squares between 500 and 1000. So, let's find the number of perfect squares between 500 and 1000. So let me look at the squares of some numbers and when it is more than 500 and less than 1000. So 20 square is 400. That's not what we want. 21 square is 441. That's not what I want. 22 square is 484. Again, that's not what I want. 23 square, this will come to be 529. So this is the smallest perfect square greater than 500. Now let us check the largest perfect square just below 1000. I know that 30 square is 900, 31 square is 961, 32 square is 1024. Fine. So that means 961 is the largest perfect score just below 1000. So I have how many numbers as a perfect square? It will be from 23 to 31. So from 23 to 31, see these are not the numbers on the card. On the card we will have numbers 521 and 961, which are the squares of these numbers. So what I actually meant is that these are the numbers that we are looking at: 23 square, 24 square, okay, all the way up to 31 square. So these are 9 numbers. Now again, many people will make a mistake here. You should not do 31 minus 23, you will get 8, and you will think, okay, there are 8 numbers. That is wrong. From 23 to 31, there will be 9 numbers, not 8. Okay, don't do 31 minus 23 and write as 8 numbers. That is wrong. Now it's simple. What is the probability that the first player will win? I have 9 possibilities out of 1000 numbers, right? So the probability will be 9 by 1000. Now we have a condition on the probability, that is the first player has already won the prize. Now what we have to check is, will the second player win the prize, or what is the probability that the second player also wins the prize provided the first player has already won the prize. So this is what we call as conditional probability. In your higher classes you will learn this in detail. Right now we will just solve this simple problem. Now remember, in this particular problem we have said that each player will select one card at random and this card is not replaced, right? That means the first player has already played the game. Doesn't matter he wins or lose, he has already played the game. That means out of 1000 card, one card is now removed because this card was played by the first player. So now how many cards are left? We have only 999 cards. Now you see the second player has to win. That means he has to get a card which is a perfect square and greater than 500. Now the first player has already won the prize. That means out of 9, he has already taken one card which is having a perfect square and greater than 500. So now we will have only 8 favorable outcomes for the second player. So these numbers we have to be very careful, and this comes because the first player has already won the prize. Since he took a card and it is not replaced, 1000 became 999, and since he has won the prize, that 9 became 8. We will quickly check one more scenario, that is probability of the second player is winning and the first player has already played a game and he has lost it. Now what will be the scenario? Again, just like the previous problem, the total number of cards available will be 999. Why? Because the first person has already played the game. That means he has taken one card already outside the box. So we are left with 999 cards. And what about the favorable outcomes? This time the first person has played the game but he has lost it. That means all the 9 favorable cards are still there in the box. So the answer will be 9 by 999 or 1 by 111. Find the missing frequencies in the following frequency distribution if it is known that the mean of the distribution is 50. We have done a similar problem before. Nevertheless, we will do it once more. So we have the mean of the distribution as 50. Now let me draw the table. So I have the table. Now I can write di as xi minus a, and since it is said that mean is 50, I will take a as 50. Then I will get minus 40, minus 20, 0, 20 and 40. I will write ui equal to di by h, and for h I will take 10. I will get minus 4, minus 2, 0, 2 and 4. Now I'll write FIUIS. I'll multiply all the F with the corresponding UI. I will get minus 68, minus 2 F1, 0, 2 F2 and 76. And we also have the information that summation Fi equal to n is equal to 120. So from this I can write, observe, 120 is equal to 17 plus F1 plus 32 plus F2 plus 19, or I will get 52 is equal to F1 plus F2. Now I will make use of the given information, that is mean of the distribution is 50. So I will apply the equation for mean. So mean x bar is equal to 50, which is the given information, and this is equal to a plus h into summation fi ui divided by summation fi. So I will plug in the value. I'll get 50 is equal to 50 because a is 50, h is 10, and summation fi ui is, let's add all these terms to get summation fi ui. Summation fi ui is equal to, you will get minus 2 f1 plus 2 f2 plus 8. I will use this here. in this particular term. Now coming back, I can write summation fi ui by summation fi. Now I'll get cancel these two terms, then I'll be able to cancel this term, then I'll be able to cancel this term, meaning summation fi ui is equal to 0. So if I simplify this, I will get summation fi ui is equal to 0. So this I can apply here. That means this equation is equal to 0. Now I have two equations in terms of f1 and f2. If I solve this, I will get the value of f1 and f2. Minus 2f1 plus 2f2 is equal to minus 8. f1 plus f2 is equal to 52. I'll multiply 2 on both sides of this equation. I will get 2f1 plus 2f2 is equal to 52 into 2, and then I will add these two equations. If I add these two equations, these two terms cancel out, leaving only an equation in terms of f2. So I will get 4f2 is equal to 104 minus 8, which is equal to 96, which means f2 is equal to 24. And once I have f2 equal to 24, I can substitute here and I will get f1 as 28. I have skipped all the small steps in between. You can practice your own. The process is simple. Once I get these two equations, I have to solve this. That are these two equations. So what I did, I took this equation, multiplied by 2 on both sides, LHS and RHS. I got this form, and then I added these two equations. Okay, then these two got cancelled, leaving an equation only in terms of f2. I solved it, I got f2. Once I have the value of f2, I'll put it back into the first equation, or any equation you can substitute, and you will get f1 value. If the mean of the following distribution is 18, find the missing frequency. Again, a simple problem. So I have the table ready with me. Now I can first find the mid values of the classes and find FIUI and use the equation for mean to get the value of the missing frequency F. Let me do that. Observe. Xi is 12, 14, 16, 18, 20, 22, 24. UI I will write as x minus, I will take 18 as my common subtraction and the h value as the size of the class interval, that is 2. 18 by 2. I will get minus 3, minus 2, minus 1, 0, 1, 2, 3. Now I can write FIUI minus 9, minus 12, again minus 9, 0, F, 10 and 12. So if I do FIUI, I will get summation FIUI is equal to F minus 8. You have to be careful in adding all the values. This is where I think most of the people will make the mistake. Now I will substitute in the equation for mean, because we have the information of the mean given in the problem. So mean is equal to x bar is equal to 18, and this is equal to, I'll substitute in the equation a plus h into summation FIUI divided by summation FI. So I will get 18 is equal to 18 plus h is 2, summation FIUI is f minus 8 divided by summation FI. Now what happens? These two gets cancelled out. This also will get cancelled out. This also will get cancelled out, leaving only f minus 8 equal to 0, or implies f is equal to 8. I will write the steps. First, these two get cancelled out. So I'll get 0 is equal to 2 into f minus 8 divided by summation fi. That means I can cancel 2 and I can take this to this side, leaving f minus 8 equal to 0, or simply the missing frequency is 8. The following distribution shows the weekly allowance of 64 children of a locality. If the mean allowance is 180, find the value of x and y. Again, it's a problem of missing frequencies. Let's do this. So we have the total number of children as 64 and the mean pocket allowance as 180. Now let me draw the table. So I have the table. Now let me write the midpoints. This time, even though it is given that the mean pocket allowance is 180, I will not use 180 when I write the UI value. Instead, I will make use of the value 200 so that I can eliminate x in one of the equation. Observe, UI is equal to xi minus 200 divided by the class interval, that is 20. So I will get minus 4, minus 3, minus 2, minus 1, 0, 1 and 2. And then I can write fi ui as fi ui. I will get, what I am doing, I am multiplying 7 into minus 4, 6 into minus 3, 9 into minus 2 and so on. I get minus 28, minus 18, again minus 18, minus 13, 0, 5 and 2y. Now two things I can write. I can do summation fi and summation fi ui. I will get summation fi is equal to n is equal to x plus y plus 40, or I can write 64 is equal to x plus y plus 40, or x plus y is equal to 24. And for fi ui I can write summation fi ui is equal to 2i minus 72. Now I will use the equation for mean because it's given that mean equal to 180. Let me do that. So x bar equal to 180 is equal to a is 200 plus h is 20 into summation fi ui by summation fi. And so I can write minus 20 is equal to 20 into 2y minus 72 divided by 64. I can cancel these two terms and I can write minus 64 is equal to 2y minus 72, or I get 2y is equal to 8, or simply y equal to 4. Now I can substitute y equal to 4 into this equation. I will get x equal to 20. So these are the final answer, x equal to 20 and y equal to 4. The median of the distribution given below is 14.4. Find the value of x and y if the total frequency is 20. So I have the tabular data here, and unlike the previous problems, this time we have the information of median instead of mean. Let's do this. Now, when we look at the median value, it's given as 14.4. So we can directly know that 14.4 will lie between 12 and 18. In other words, the median class is going to be 12 to 18. So this is one thing that we have to understand from the given information, that is median is 14.4 and 14.4 will lie between 12 and 8. Therefore, the median class is 12 to 18 with the frequency 5. Now we will use the equation for median and use this information of 14.4 and compute the values of x and y. So first of all, we have the total frequency as 20, and this is going to be equaling 4 plus x plus 5 plus y plus 1, or you will get x plus y to be 10. Now the median equation, median value is 14.4 and it is equal to L plus n by 2 minus Cf divided by f into h. Therefore 14.4 is equal to L is what? L is the lower limit of the median class, so that is going to be 12 plus what is n? N is the number of observations, or 20. 20 by 2 minus what is Cf? Cf is the cumulative frequency of the class preceding the median class. So the class preceding the median class is 6 to 12. So what is the cumulative frequency up till here? It will be 4 plus x divided by what is f? F is the frequency of the median class, or 5. What is h? H is the class size, or 6. Now in this entire equation, only one unknown is there, that is x. So we can quickly solve 14.4 minus 12. Then we take this 5 and 6 to other side. Similarly 20 by 2 to the other side. Isolate x, solve for x, you will get x equal to 4. 2.4 into 5 divided by 6 is equal to 10 minus 4 minus x, or you will get x to be 4. Now take the value of x, substitute in this equation, and we will get y as 6. So the answers are y equal to 6 and x equal to 4. The monthly expenditure on milk in 200 families of a housing society are given below. Find the value of x and also find the median and the mean expenditure. So I have the table ready. Now I'll first write the mid values. Now I will write the ui value, and ui equal to xi minus, I'll take the mean, or I'll assume the mean to be 3250. The assumed mean is 3250, and we have the class interval to be 500. So I can write ui is equal to xi minus 3250 divided by 500, and I can write minus 4 minus 3 minus 2 minus 1 0 1 2 and 3. Now in the given problem we have the information that this whole data is for 200 families. That means the total frequency is going to be equaling 200, and from this we can find the value of x. Let's do that. Summation fi is equal to n is equal to 200, and this is equal to the sum of all these terms, and when you do that we get 172 plus x, or x equal to 28. So I can write, now I'll compute fi ui. So I'll multiply fi with the corresponding ui, fi with the corresponding ui, and for x I will use 28 with the corresponding ui, and I will get minus 96 minus 120 minus 66 minus 28 0 22 32 and 21. Now if I add all these terms, I will get summation fi ui is equal to minus 235. So we have found the first part of the problem, that is the value of x. Now I have to find the median and the mean expenditure. So let's start with the mean. Mean is equal to x bar is equal to a plus h into summation fi ui divided by summation fi. So here assumed the mean as 3250 plus the class interval is 500 into minus 235 divided by summation fi is 200. Now you do the calculation, you will get x bar to be 2662.5. This is the value of the mean. Now let us compute median. Median is equal to L plus n by 2 minus Cf whole into h divided by f. Now before we solve this, we have to find the median class. The given data set is for 200 family, so the median will lie at the 100th family, right? 100th value will be the median value. So where will 100th family lie? So 24 plus 40, I'll get 64 plus 33. 64 plus 33, how much I will get? 97. 97 plus 28 is definitely more than 100. So the median class will be 2500 to 3000. Right? The 100th value will lie in this particular class. That is, we have to add the frequencies until it crosses 100, and that is in this particular class interval. Now I can solve. The value of L is nothing but L is the lower limit of the median class, and that is 2500. 2500 plus N is 200. 200 by 2 minus Cf. Cf is the cumulative frequency of the class preceding the median class. So what is the cumulative frequency of the class preceding the median class? If I will just calculate here for the sake of clarity. So I'm not going to write all the value. All we need is, this is the median class and the class preceding the median class is this, and for this particular thing the cumulative frequency is 97. So we will use this in the equation. So Cf is nothing but 97 whole into h. H is the class interval, that is 500 divided by f. F is the frequency of the median class, and that is 28. And you do the math, you will get 2553.57. So we have computed the mean and the median value.